On the behalf of Department of Mathematics and Department of Statistics, Amity Institute of Applied Science, I, Dr. Sudeepa Chauhan, welcome all the participants, eminent speakers, and faculty members to the 5-day workshop on computational tools for research in science and technology 2021. No wonder that the community of academics uses the word workshop as a synonym for distinguished or unique classrooms. Learning in the form of passionate interactions, participations, expertise, networking, and motivation is what when we talk of a workshop. We are dedicated to making this experience of yours likewise. While education and knowledge may strike you through various interfaces, a workshop has a unique manifestation in the form of enabling, spurring candidates to investigate new concepts through their sense of understanding. As interesting as it gets, intertwining with hands-on experience or more appropriately, practicing in safe hands. Amity University has always ensured that its students, participants from academics and industries not only stand at par with the global community in terms of standards of education, but also mark their distinguished presence through innovations and advancements. Following the legacy, we are conducting this workshop on the emerging tools pertinent to research in different domains of science and technology. Before proceeding further into the detailing of the workshop, I would first like to invite Professor Dr. Sunita Ratan, Director, Amity Institute of Applied Science and Dean Science and Technology domain, to express her research enthusiasm as this workshop takes place. Professor Ratan is herself a milestone in research in various domains like nanocomposites, smart hydrogels, to name a few. She has numerous accolades with both national as well as international to her name. It is always a delight to have an expert speaking on expertise. Ma'am, please may we have the opportunity of being enlightened by you.
Thank you so much, Sudeepa. Honorable Vice Chancellor, ma'am, our keynote speaker, Dr. Pandey, all the dignitaries, all the resource persons, a very, very good morning to all. First of all, I would like to extend my greetings to one and all present here. This workshop, which is very apt in today's time, when we talk of science and technology, the inclusion of different softwares make our science and technology work much, much easier. When we talk of analysis, accurate result, they stand on the top of any scientific analysis. And this workshop is going to help our students who are from mathematics, statistics, physics, and chemistry to know about these softwares which can make their work easy, which can give them an accurate and refined analysis so they can do a number of things in their, and they can get good publications in matter of days rather than when it used to take months. So this workshop is very, very apt. It has made an attempt to cover the length and breadth of tools and softwares that will aid budding apprentices and enthusiastic, even industrial trainings to hone their skills in the same. We are including Maple, MATLAB, Scilab, R, Python, and LaTeX, which cover entirely a broader spectrum of science and technology. And we can have high impact education in this. And this will also help us to go for the interdisciplinary research. Because when we talk of maths, when we talk of physics and chemistry research, the researcher in those fields really feel that he should be knowing something statistical tools, some type of software. So this is going to bridge that gap between these two. And the students for mathematics and statistics, they are going to learn these new, very, very apt, very, very important softwares. And I know that the faculties or the organizing members, they have done a lot of work. And I'm also thankful to all the resource persons who are distinguished in their field. They are expert in their field. that our students are going to learn a lot. And I'm very happy to learn that it's not only the students, even the faculty members are interested in joining some of these softwares, because this is going to help in their research also. So with this, very I congratulate the team for organizing this value education course, and I know each and every participant would be greatly benefited by this research. And last but not the least, I would also like to thank our Honorable Vice Chancellor, ma'am, because whatever she thinks is very, very apt in today's time. And this value addition courses, these are the additional courses which she has taught, are going to be greatly beneficial to our students. And not only we are going to have this workshop, we are going to have a series of workshop only because ma'am is there with us. Thank you, ma'am, and thank you all. Thank you so much.
Thank you so much, ma'am, for your motivational uh, thoughts on this particular workshop. Now, may I please have this opportunity of inviting one of the building blocks of our institution, Professor Dr. Balvinder Shukla, Vice Chancellor, Amity University, Uttar Pradesh. Her thirst for knowledge and quest for excellence took her to various institutes of repute and designations versatile and challenging in nature. More than 3 decades of grittiness, her specialities includes strategic management, resource-based strategy, business restructuring, etc. Ma'am, please may we have the pleasure of absorbing your pearls of wisdom.
Thank you very much, Sudeepa. My very esteemed colleagues, Dr. Sunita Ratan, and all the faculty of AIS, and especially the mathematics department. First of all, I would like to congratulate Amity Institute of Applied Sciences for organizing this very important workshop on the for the computational tools, um, because it's very important that we understand in today's environment what are the various the computational tools and techniques which can be used by the researchers, not only for their research purpose, but also for developing the skills and competencies for the industry 4.0 requirement. Though we have been using in engineering the math lab and science lab, but in the teaching, especially at the undergraduate level and the master's level, I think this need to be enhanced many folds, because for last 1.5 year almost, while we are away from the campus, and all teaching learning is a remote mode of teaching. So how do we take the help of the technology, uh, one side for the better, um, the for better teaching learning, and secondly developing the requisite skills for the industry. So therefore, workshops like this on various softwares and the various tools which are very much applicable in the the in the industry domains, and which need to be faculty or the students and the scholar need to hone their skills in those areas, whether it's Maple or MATLAB or Science Lab, or the Python or the LaTeX, which all cater to the needs of um, the skill development for the graduates and postgraduate and scholars, and which has a very high impact on education, as well as caters to the industrial needs. So whether you talk about the computational tools, or whether you talk about the, because if you have the understanding of the computational tools, you can further move to the computational engineering. Because if you say that today the something which you cannot do in the lab environment, but you can do in the simulated environment, and so therefore the computational uh, tools, techniques, and the computational engineering becomes extremely important especially in the industrial sector. I'm sure this workshop is going to be very very useful uh, for for all um, community of the university, of the institution, whether it's the students or whether it's scholars or even the faculty. Um, because uh, the, st- uh, the student need to also understand that how we are able to develop our the networking skills. And I think the research gates plays very very important role, and where the scholars can network with us, with the collaborating with the from the with the faculty or the researchers from the other institutions, which can create a really good conducive environment for the research. And if you really want to, because today the collaborative research is extremely important, so that the teams can work on the important problems or areas which eventually will be useful for the industry. So with this, once again, I congratulate team Department of Mathematics and our Dean Dr. Sunita Ratan, and wish all the best to all the participants, and also the wish all the best for the success of this workshop. God bless you.
Thank you so much, ma'am. Thank you.
Thank you so much, ma'am. I hope with your blessings, we would be successfully conducting this workshop. And now I would like to invite my colleague, Dr. Rupakshi Mishra Pandey, to elaborate on some specifications of the workshop and excavate our intentions around it. Dr. Rupakshi Mishra Pandey, over to you.
Thanks, Dr. Sudeepa. It's a glorious moment to extend our warm wishes and welcome you all to the 5-day workshop CTRST 2021. This workshop will encapsulate comprehensive theoretical and hands-on practice on important computational tools and software used in mathematics and statistics. The aim of this workshop is to develop proficiency in these essential softwares. Mathematica is a symbolic mathematical computation program used in many scientific, engineering, mathematical, and computing fields. Scilab is the open source software for engineers and scientists that provides tools to perform data analysis and modeling. Today, we will start our first day of the workshop with the session of Mathematica, which will be delivered by Dr. Saroj Sahani from South Asian University, New Delhi. And then in the post-lunch, the Scilab session will be taken by Dr. Lata Chanchnani, University of Rajasthan, and Dr. Pratibha Manohar, SKN Agriculture University, Jubilee. Maple is a symbolic and numeric computing environment programming language which covers several areas of technical computing. Also, the SPSS software offers advanced statistical analysis, a vast library of machine learning algorithms. Session on Maple and SPSS will be conducted on the second day of the workshop, that is on May 25 by Dr. Milind Srivastav, Gautam Budh University, Dr. Neeraj Kumar Singh, and Dr. Karsh from Amity University. 26th May will be a day break. Now come to the third day of the workshop, that is on May 27. We will have sessions on MATLAB and our software. MATLAB is a programming and numeric computing platform used to develop algorithms, create models, matrix manipulations, plotting of functions and data. It is frequently used nowadays by academicians in their research. Also, our language is widely used among statisticians and data miners for developing statistical software and data analysis. This session will be delivered by Dr. Saroj Sahani and Dr. Anup Kumar from Sanjay Gandhi Postgraduate Institute of Medical Sciences, Lucknow. On May 28, we will continue the session on our software by Dr. Anup, and then session of Python will be given by Mr. Anant Avasti from Gentech and Dr. Neeraj Kumar Singh from Amity University. LaTeX is high-quality typesetting system which includes features designed to produce technical documentation and is standard for the communication and publication of scientific documents in their research. The last day of the workshop will include session on LaTeX by Dr. Lata Chanchnani and Dr. Pratibha Manohar. On that day, Dr. Vidya Kumar Tripathi from Ramanujan College, Delhi University will also introduce some research tools such as flowchart, light chart, ResearchGate, and ORCID. Now, I would like to mention here that feedback and assessment will be taken at the end of each session, for which Google Form link will be shared in the chat box only. In addition, the link of the final feedback will be given after the valedictory function. Also, the e-certificate will be provided to those participants who will successfully complete the workshop, which will be decided by feedback, assessment, and attendance. Participants are requested to use checkbox for query. They are also supposed to join every session on time and be ready with those softwares and tools for which user guide will be sent prior to the session day. Now I invite Firdaus, research scholar, Department of Mathematics, to take the course of the workshop further. Wish you all the best, participants, and enjoy learning. Thank you.
Thank you so much, ma'am. Am I audible?
Yeah, you're audible.
Okay. A very, very good morning to all of you. It gives me immense pleasure and sheer excitement to introduce our keynote speaker for this workshop. Professor Arvind Pandey heads the National Institute of Medical Statistics, Indian Council of Medical Research as the director. He is a veteran in the field of statistical modeling, population science, and epidemiological studies on communicable and non-communicable diseases in India. He has served as a director, ICMR, National Institute of Medical Statistics, for over 16 years and as a consultant for World Health Organization for the year 2018 and 2019. He obtained his PhD degree in statistics in the year 1981 from Banaras Hindu University, and his quest for knowledge took him to University of North Carolina at Chapel Hill, USA, as a Rockefeller Foundation Fellow for his postdoctoral training in 1986-88. His area of teaching and research includes demographic models, survey methodology, estimation, and projection of HIV and clinical biostatistics. Sir has authored over 230 peer-reviewed articles, 12 books, and over 45 research monographs and reports. Over 18 students have been awarded the Philosophy of Doctorate under his supervision as well as co-supervision. He is the member and chairman of over 30 research and technical advisory groups constituted by the ministry. He has established the Clinical Trials Registry, CTRI, as National Repository of Clinical Trials in India, one of its kind for the registration of all the clinical trials by teachers, researchers, and the industry. Besides, he has been the president of the Indian Association for the Study of Population, IASP, for consecutive years from 2006 to 10, and Indian Society for Medical Statistics for the years 2008 to 2010, and the chief editor of Demography India, a journal published during the years 2002-2006. Professor Pandey is presently a member of India's National Task Force on COVID in the Operation Research Group. He has been awarded the prestigious Professor P.V. Suktame Memorial National Award in Statistics for his lifetime contributions and achievements in the field of official statistics by the Government of India on implementation, and this award was conferred to him on the Statistics Day, 29 June 2020, birthday of Dr. P.C. Mahalanobis, father of Indian statistical system. Sir, may we please invite you for this session and have the pleasure of having you with us. Sir.
Yes, can you see me and hear me?
Yes, sir, we can see you and hear you as well.
Thank you. Thank you very much for so elaborate introduction of mine. Good morning to all of you.
Good morning, sir.
Respected Professor Balvinder Shukla, Vice Chancellor of the University, Professor Sunita Rattan, who is Director and Dean of Amity Institute of Applied Sciences, your CTRST team, Dr. Neeraj, who motivated me to participate in this workshop, and my dear participants. I'm really very happy to see this momentous workshop, and also I listened Professor Sunita Rattan and also the Vice Chancellor. In fact, they have given the overview of what, in fact, a keynote speaker should have spoken. So I'm really very happy that they are having all these things in mind. So I'm very happy. And for the second time, I'm getting connected to Amity. About 10 years ago, or maybe more, Professor Sunita Rattan had invited me to the university for some occasion, I don't remember. And there I had occasion to meet the wonderful faculty and students of the Amity University. As I heard from them and also hear from all of you enthusiastic organizers and participants, this workshop which we have planned is really wonderful in the sense that nowadays statistical software are very costly and they are having all sort of points or riders on that on their use. Sometimes they not sometimes often they encourage that if you are using their software, you mention in your research paper, and so that they know that such and such person is using the software, or if person is saying that he or she has used that software but not have subscribed that, or they have not purchased, they may be questioned. So from that angle, it becomes really challenge for the Indian researchers or researchers from the developing world to buy individually those costly software. And for that reason, we have been encouraging that we should use the software which are freely available or who are in the Google. So from that angle or the spirit which I had, I felt very happy that Amity has taken initiative to have, I will not say workshop, I would say that this workshop is a beginning of the larger capacity building. And also what Professor Sukla has said, networking of the skill, and a skill which is available within our network, and whenever we want, we can use it. And all of us are aware that data is precious. Data is the basis for any decision, any activity. And in present time, we are seeing the COVID itself. Very often we keep hearing from different quarters that such and such data we don't have, or such and such data we have. Based on that, we have taken this decision. So data is important. Data has its own language, and that language we need to understand. And until now, understanding of those data and the issues were limited to those who were applying that. But in the current period, when a lot of development has taken place for analyzing the data, a lot of software are becoming available. When software become available, that means technology is available, and technology has really advantage from that front that it is available. And if we train the people, or people can just see nowadays, if you go on Google search, you can get even guideline also how to use those software. So if that is there, then there's no use of any workshop. But data has its own problem, and data has sometimes some context. Data has some situation, some objective with which that have been collected. And if we are not understanding that, then probably we may have misleading inferences. I keep quoting at several places that there are issues related to selectivity, there are issues related to ascertainment plans, how the data has been collected, and what were the objective behind those data. And if we are trying to have something else, we always say that you can have analysis, no doubt, but you will have as a secondary objective. And that secondary objective is not limited to the power of the analysis, but indication. It gives an idea, it gives the basis based on which you can think of some new analysis or some new studies which you can plan. So that way, this data understanding is very, very important. And that's why if workshop is organized by the people who are understanding theory, who understand the assumptions, and then if analysis is carried out, then only we'll see that these are the inferences, quote under quote, with some riders we are giving to go ahead. So that's why for taking any better decision, data is important, but at the same time, if it is known what are the behind assumptions, and suppose someone else comes and says that, look here, I have collected the data, but this gives some different result. Now, how to counter that? If you are analyzing a data, you should be in a position to see that it has all those basic design of experiment. If not, then we can say that these were the limitation, or this particular principle was not followed, and that may be the limitation. And so if we are comparing, we can ask other person also that what are the assumptions under which your data has been collected or has been brought here to at forefront for the analysis or drawing inferences. So inference drawing is very easy from the known facts, but if those known facts are not properly understood, it may give misleading inferences. And earlier, we used to do by hand all these analysis. In the beginning, we should do by hand. But now I'm happy the software which are listed here on which we are going to give training, that makes us more efficient and also move forward. For example, the first one I was seeing Mathematica. Mathematica is very powerful tool to solve our differential equation of different order very easily, with which we used to take a lot of time. Of course, we are of those days when we used to solve ourselves and then only say that just put the result, you will get the output. But now, since we are increasing our order of differentiations and conditions in mathematics, we are bringing statistics, means the variable is becoming random variable. Then this our differential equation becomes more and more complex. And that situation, if we have large number of differential equations set and we want to estimate the different parameters in that, we will require software like Mathematica or other Skylab. These are the software. If our researchers are familiar with that, they can understand. The example I will give you presently that, SIR model, susceptibility, exposed, inspections and recovery model requires to develop a set of differential equation. Of course, in that the input which is required, that comes from demography. So one should have knowledge of the demography, one should have understanding of the system, then only you will know that how many people are susceptible, how many people are getting infected, and how many people are getting recovered, and susceptibility means the whole population, whether the whole population is susceptible or not, and then how much our system is bringing that. So if this knowledge is available, so that means 4 or 5 parameters is available, then we can immediately apply and try to solve the differential equation with the help of this software. So if this software our people are familiar with, they can see how this in this era or in pandemic situation, we are estimating how many deaths are taking place. How really, because when we hear today newspaper itself is saying that India is number 3 in terms of getting the quantum of deaths. Yes, it may be because of our own size, our population is big, but through this model, if you put and whatever assumption we have taken, susceptibility, infection, recovery, and all those, then we should be in a position to know whether this death which we are providing, whether it is really true or it is little bit underestimate. That also we can provide. Or sometimes if we are not having data, we can estimate also based on other 3 parameters for which knowledge is available. So that could be possible if our people are familiar with, and more brains always helpful to see whatever one person is giving or predicting based on a single assumptions or understanding. So that way, the more understanding of the data, treatment of the data, the problem and issues in the data. Sometimes data, for example, if you see your Arogya Setu, lot of informations are being collected, and in that everyone is complaining that the custodians are not sharing this data with the other researchers so that we can analyze. There is no need of waiting for that. If you watch our TV every day, you can note down how many new infections, how many tests have taken place, how many new infections, how many recovered, and how many deaths have taken place. Based on this information, if you are really a good model builder, you can estimate the likely effect of the interventions or not. We are not getting any effect from this. So if we are having this skill and the understanding of the data and the issues, we can always estimate from there. So those kind of things are possible. So what I would say that data is very powerful. It's powerhouse of our science, but at the same time, if powerhouse is not properly handled or right engineer is not there, then you may have some kind of chaos situation. So this software, I am happy that are being shared with the participants that look here, this is a shop in which all these items are available. You just try to get into, learn it, but I would suggest that you need not to be no master in everything. You should have knowledge of one and expertise in one, but you can have knowledge of others, so that whenever you want to compare any of the result uh, or validate any of the result, always you can take other software or other models, so then you can say that you are confident that whatever you are getting by one methodology, same is other. I would like to not mention the name of a software, but I tell you, I was using two software about 30 years ago when I was in the United States, and I found that by one software I was getting one result, by some other software I was getting other result. Then I informed to the people that look here, we are getting this result, which one to believe. Then I was subsequently told that second software has some problem and first you can accept. So if I did not have that knowledge of both, I would have not been able to compare. Of course, in the beginning, we always suggest that when you are analyzing data, you should carry out a small exercise first by hand, and then only you start using the software, so that you know the mechanics inside what is happening and how the result is coming, so that you understand the or interpret those results. So that way it becomes very important. And so, another example I would like to give you, that I have been working in the area of HIV/AIDS. You remember that in late 90s and early 20s, we were getting very high estimate of HIV. How it was coming? We had certain assumptions. That time when limited data was available, we were estimating based on those assumptions, and we said that this is what is the estimate. And that number was increasing like anything under those assumptions. And a time has come when India was likely to surpass Africa also in terms of the number of HIV cases. Then suddenly one bureaucrat, those days secretary of the ministry, pointed out, how come this is coming? She questioned me. Dr. Pandey, can you show me these many people around? I will recommend your name for Nobel Prize. See, like that she said. So I said, ma'am, why are you saying like this? But this is what the assumption. She said, okay, don't always blame assumptions. You say that these are the assumptions when in the beginning. But now time has come when you can relax those assumptions, you can validate those assumptions, or if methodology required modification, you can do it. So there we said, but again, we have to take a task when whole thing will be revised, maybe revised, and then if new results come, how the government will adjust. Government will take, the actions which earlier has taken different, that may be changed. Then there we get support of the bureaucrats. Don't worry, if science is corrected over time, we can always go back and see that how our program could be modified. So those kind of support is needed from the bureaucrats and from the politicians. But before that, we need to explain to them that this is what the methodology, this is what the assumption, and under which this kind of result we have been getting. Similarly, in case of this pandemic also, we are getting different kind of experiences, and data is coming. people say that how this, Covishield has become suddenly from 4 week, from the interval between first dose and second dose, 4 weeks to 6 weeks, and then it became 12 weeks. Suddenly, how it became? So what you might have seen on the TV that our secretary came and he said that this morning we had discussion with some scientists and also some new data we got, which is showing that we can optimize its benefit if we can increase, the interval between the first dose and second dose. So that means he got that data and also the mind of the scientist who are involved into that, and then only the decision could be taken. So that required waiting time. Some waiting time is needed, and if waiting time is not available, we begin with. So we are never wrong. So we should never blame that science has been wrong, but science, whatever evidence is available in the beginning based on certain assumptions, they move, and then after that they go on modifying or correcting whatever new evidence they generate. And in that, this kind of the software which are freely available, that helps that everyone brain can work and can be used. So in that way, I feel very topical. This workshop only by caution would be that you have collected so many software together, and in 5 days time, I feel that you may not be able to do justice really. That all the software you will give just introduction, and then you may have to organize again and again on each topic 1 week workshop, so that you can see that out of these participants and also additional participants who are really interested in particular software to use, so that you can train them and really you make that skill network. What Professor Sukla has said in the beginning, that skill network you can make it stronger. By this workshop, I must say that you are just giving them the test of tea, and later on you are going to offer greater different quality of tea so that they can test. So with that, I would always give my best wishes to the organizers, to the university, and also the participants. All the best that in this 5 days, because wonderful speakers, resource persons are there, and I am sure they will give good input and motivation, so that they start working in their areas. For example, Dr. Sunita Ratan has mentioned about physics also. There are some people are from physics, and I remember when I was in fresh graduate, the graduate means PhD in statistics, and someone came from physics and asked me, can you analyze this data? Whereas I was from life science. My PhD in statistics was from the life science area application. I had difficulty. I had to spend whole day to understand what is the data and then how this can be analyzed. So that way, it is very good that you have called this physicist also in this, so that they understand this software, they understand the basic statistical requirement, and then they can analyze their data in a more effective manner and without losing much time, or motivating statistician also to work in different areas, because statistician cannot be trained in all the areas. If you go for that example is that Indian Statistical Institute, Kolkata. There, if you go, you will find that in a statistical institute there is a physics department of physics, there is a physics department of chemistry, there is a department of geology, department of anthropology. Means statisticians should be working with all those disciplines to understand their requirement and also use these different models, different mathematical models, statistical models, and also the analysis in a right manner. So that way, it's really good that you have amalgamation of the participants from different disciplines. That's really great, and I can wish you all the best. With this, I thank you once again for inviting me for this. Thank you. Thanks. It's over.
Yeah, thank you so much, sir. It was really pleasure hearing you all and the varieties of the softwares, the detailing which you have spoken on. And we are definitely looking into this, that in future, once we get the interest of the participants, we will be surely organizing more workshops specifically on each of the softwares as you suggested. So that is again there in our pipeline. Thank you so much, sir, for your wonderful thoughts. Yeah. So now I'll pass over it to Payal Rana. Can't see you, Payal.
Good morning, everyone. My name is Payal Rana, Research Scholar of Department of Mathematics. And on behalf of Department of Mathematics and Department of Statistics, Amity Institute of Applied Sciences, I would like to extend a very warm welcome to all of you to this session. The first session of CTRST 2021 is on Mathematica. Mathematica is a symbolic mathematical computational program, sometimes called a computer algebra program, used in many scientific, engineering, mathematical, and computing fields. For today's session, Basic of Mathematica, Solutions of ODE, and related topics will be discussed along with hands-on session by eminent speaker, Dr. Saroj Sahni. Dr. Saroj Kumar Sahni received his PhD in mathematical biology from Department of Mathematics, IIT Roorkee in 2008. He is presently working as assistant professor in the Department of Mathematics, South Asian University, New Delhi. Prior to this, he was an assistant professor in BITS Pilani campus in Mathematics department. He has more than 10 years of teaching and research experience. His research interest is mathematical biology. We are now ready to begin the proceedings of this session. If anyone has any question, you can put it up in the chat box and they will be addressed at the end of the session by the speaker. May I now request Dr. Saroj Sahni to please proceed with the session.
Yeah, good morning all. Can you hear me?
Yes, sir.
Okay, so firstly, I would like to thank all the organizer for inviting me to deliver this topic, something on this topic, and so let us begin straight away to our presentation.
Is there any issue in sharing?
No, I just there is a system. So is my screen visible to you?
Yes, sir.
Yes.
Okay, so in this particular lecture, I have divided this session into certain subsection. So first, we'll talk about some important things about Mathematica and some basic things. Then we'll come to the next topic, which is functions. So how to define some functions in a Mathematica. Then we'll talk about how to do some algebraic manipulations and all kind of stuff in our day-to-day life. So we'll talk in the heading algebra. Then something about complex number we'll discuss later on. Then of course, the most important thing is being calculus, that is differentiation, integration, and all those points. So that we'll discuss after this. And since our aim is to do the plotting, solve the differential equation after all. So we'll first do the plotting, basics of plotting, how to plot the solutions and all the functions and related things. And then finally, we'll come to the differential equation sections. So where we'll talk about the not only symbolic different solving of differential equation, but also numerical solutions. So let us begin with the first one. So as you know that Mathematica is actually a symbolic package, mainly a symbolic package. If I say mainly, means that it has some capability to do numerical calculation as well. So mainly we use the Mathematica for symbolic kind of calculation. So as far as other software is concerned, for example, MATLAB, it is basically a numerical package. But if you compare with this, Mathematica is actually we mainly use for symbolic one. So it is a computer algebra system, cache. So where we can manipulate everything which is based on some symbols, which is otherwise impossible to do in MATLAB unless we don't specifically use some package which are actually not come with MATLAB, basic MATLAB. Okay, so to begin with, whenever you start a Mathematica, there are two things here. One is your front end, which actually users interact with Mathematica. And the second thing is the kernel. So kernel is basically the computing machine which Mathematica does in its own, and then it displayed to the user one in the front end. So whenever we say that, whenever we type, for example, let us say 2 plus 2, then it is showing in the front end that it is 2 plus 2. But once we enter it, that is once we put this into Mathematica, we simply use the keyword shift plus enter, and then it will automatically show you the result. That is 2 plus 2 is 4. So Mathematica will do all the calculation in its background, which is called kernel. Okay, so kernel, if you talk about kernel is basically an engine, computation engine in Mathematica. And whenever you start Mathematica, kernel doesn't always start unless you do any calculation. So at a starting point, the kernel is actually not active, but once you do start a calculation, it will automatically start the kernel and give you the answer in your front end.
Yes, sir. Yes, sir. You can continue, sir. Yeah.
Yeah. Okay. Yeah, so kernel, it will only work in background. It will not show you in any to you. But if you want to stop any kernel evaluation, there is a way to do the kernel, stop the kernel evaluation by just going to tab kernel and quit kernel or local kernel, whatever you would like to do. Okay, so that is the things. And Mathematica, whenever you open in Mathematica, you always do in creating a notebook file. So just you create, go to tab file. We'll come to this on later on when we do a hands-on. So I'm just giving you the first basic things about this Mathematica. So whenever you want to do any calculation or anything in Mathematica, you just go to file and you start with a new notebook, and notebook is your front end or the user interface which you interact with the Mathematica or even a kernel. Okay, and you can name this file to your own preferences depending upon your choice by just usual things, that is file save as or files save and so on. Okay, so now when we say when you start any Mathematica session, it will start with a unnamed notebook file, and in that notebook file you have two options, basically two options you have to interact with Mathematica. One is your just typing all the inputs with your keyboard, whatever symbols is there in your keyboard, you can type every functions, every command in Mathematica with your keyboard. But there is actually another way of using certain symbol, for example, integral sign, differentiation sign, or matrix sign, and so on, with a palette. So there is a palette window in the Mathematica menu where you can find all the symbols that you want to use it. Okay, so whether it is a subscript sign or superscript sign, or some symbol like pi, infinity, greater than, less than, equal to, and all those inputs are there, all those keywords, all those symbols are there in your palette one window. Okay, so this is one way, another way of writing or giving the commands in your Mathematica. Otherwise, you can always do with the help of your keyword. Keyword is basically sufficient one to write every command in your MATLAB, which is called textual form. So whenever you use keyboard to write any command, that is called textual input of the Mathematica. Or and there is a symbolic one or natural math notation of this one. For example, if I want to write this integral sign, okay, if I want to use this integral sign, then it is always good to get those palette from the palette window, these symbols from the palette window. Otherwise, this integral can also be written in terms of textual command. For example, just you write integrate, and this is also functions as this integral symbol. Okay, so the same integral can be written in this form, like integrate within the bracket, a square bracket, the functions. So function could be x divided by a square root. SQ is again, there is a symbol to write, there is a palette to write a square root, but otherwise you can write it as SQ RT and then 1 plus square root of x raised to power 6. So this is 6 x raised to power 6, and then the your usual variable, that is I want to integrate in with a variable x starting from 0 to infinity. Again, infinity can be written as a textual form, this one, or your usual palette window, that is infinity sign from the palette window. So the same thing, same integral is written in natural math notation as well as the textual form. So every command you can write in a textual form as well. Okay, so you can do like this one. So when we'll use, when we come to hands-on, then we'll talk about this thing in more elaborate form later on. So again, if you stuck at any point of time, if you want to have any help about that, any command or any function, you can always use the help window from the Mathematica menu itself and write your whatever you want to get help, write some keyword, and Mathematica will give you the help about that one. So for example, if I want, if I write Fibonacci, then Mathematica will give you how to use this function and where to use it. So that will become a, so in the your front in your notebook, you simply write question mark followed by Fibonacci, and the all the help menu will be get displayed in your notebook itself, which will give you how to use those functions and where to use it. Okay, so what are the options available in Fibonacci numbers? So that will be given by question mark followed by your keyword. Similarly, if you want to have more information about that one, you can use the double quotation mark and double question mark and then followed by the keyword Fibonacci. For example, you can also write plot. What are the plot command which is available? So if I use question mark plot, then all the plot which is available in Mathematica or which Mathematica supports will be given in this form, and then you can go to each of this one by one. Okay, similarly you can have plot. So there is another kind of plot which is available, which has a plot inbuilt. So a star plot, a star means any function with the keyword plot in them. So for example, absolute argument plot is there, one of the function which is a plot in that one. So all these things can be displayed in the Mathematica, and you can go you can go to the intended.
Sir, you are muted. Please unmute yourself.
Okay.
Yes, sir. Fine.
Okay, so I just said that whenever you want to have any help, then you have to just write question mark with a followed by keyword, or double question mark with followed by keyword, or anything like that. So for example, plot, any command starting with the plot keyword will be displayed with a question mark plot with a star, and any functions with plot having in them will be displayed by question mark star plot star. Okay, so a star plot star means any function in Mathematica, any built-in function in Mathematica which has a plot header or plot words in them. Okay, for example, list line plot is one plot, Mathematica plot which is used to plot the list list one or matrix one. Okay, so in that one you can use. Okay, so input in Mathematica there are some inbuilt functions. There are so many inbuilt functions which you can think of. For example, Bessel function and so on, they are there. You can use help command to get information about that one. Okay. Now let us come to the important thing about Mathematica. So how to names any variable or any function in Mathematica. Whenever you want to do any calculation, you have to first name the variable. So name of variable is very easy. What you have to do, you have to write the name which will begin with a letter, okay, but may include the numbers anywhere after the first character. So for example, Basel 1, 2, 3, or anything like that can be named with the name. Must not contain any of the things. So for example, underscore, uh, plus, minus, slash, that is division sign, colon operator, question mark, or a star. This is not this is not allowed in naming a variable or naming a function. Name cannot include embedded spaces. It cannot include this one. Name cannot be duplicate a reserved name. For example, n is a name which is already assigned in Mathematica, which is used to calculate numerical values of any expression. So you cannot use any reserved name which is actually in the Mathematica itself. So you have to write any other one which is other than the reserved keyword. Okay, so this is the most widely used the name, that is M, N, N, P, Q, R. All these things are actually used widely, but N is a keyword which you should not be using in Mathematica. Otherwise, it will show you error. Okay, so for example, N is protected symbols. You cannot use this one because it is already defined function. So n is a expression, n is actually a quantity which is used to get the numerical values of the expressions. So there are other reserved keyword, for example, very small reserved keyword, that is n is for numerical calculation, numerical evaluation, or numerical calculation of any expression. I, capital I, is again a reserved keyword. You should not use it for any of the looping structure. For example, I, J, K, we always use in a loop, but this is not a this is not allowed in Mathematica. So capital I is used for imaginary quantity, imaginary unit. Similarly, E, capital E, again you are not allowed to use it because this is used to get the exponential function, exponential constant, that is E. Similarly, this C you can also not use, should not use it because this is used for constant of integration. Okay, whenever you do integration, the constant of integration is actually given a name or given by a name C, C1, C2, and so on. Okay, so you should not use it. Again, D is used for partial derivative. You should not be using any of this reserved keyword which is actually defined previously in Mathematica. So you are allowed to, you are free to allow any word. You can use n1. For example, n1 you can use it because n1 is not defined. Similarly, I1 you can use it, and so on, because it is as per the name structure, naming structure. You can use the number, you can use the variable with a letter, starting with a letter, and this may include a number anywhere after the first character. So it is allowed. So n1 is allowed, I1 is allowed, but n, I, E, C, D is not allowed. Okay, so all these things you have to be very, very conscious. Similarly, there is a pi, P, capital, starting with a capital P and then followed by I, is used to get the pi number. Okay, so these are the things. For example, if I use D is equal to 3, D again a small, this is I'm using a small d. So there is no question of mm, undefined definition. There is no question of, there is no question of definition being mismatched with the previously defined mathematical constants. So D is actually a small d is, you can use it. So D is equal to 3 is actually a valid naming of the variable and assignment operator. So equal is a assignment operator. We'll talk about later on. Similarly, D, so whenever I use D is equal to 3, that means D is a variable which has a value 3. So whenever I write D and enter it, Mathematica will show me the number 3, which is the actually the values of this quantity. Okay, so one thing you will you will see that since Mathematica is being a symbolic one, you can start using the variable without assigning any of the variable, its parameter or variable itself. For example, I can name a variable named quadratic with assignment with its value as ax square plus bx plus c. So a, b, c, and x are all symbols. Okay, so in Mathematica this is allowed, but in MATLAB this is not allowed unless you don't specify the values of a, b, c, and x. MATLAB will not be going to handle this kind of expression. But since Mathematica is a symbolic one, this is allowed, and this is you can use it wherever you want. Okay, so quadratic equal to x square bx plus c is actually valid naming of the variable quadratic, and this is actually the variable value, which is ax square plus bx plus c. So later on, this expression can be work as a function as well. Okay, so whenever you want to do the derivative of this function, you can use it with other derivative operators, for example d. Okay, so quadratic is a variable name. Quadratic, when I write quadratic and just enter it in the Mathematica, it will show me the values of this expression. Similarly, there is another command in Mathematica to get the expression naming of the things. For example, set variable. So set is previously defined inbuilt Mathematica function, which can be used to define, or which we can use to get the values of the expressions. So for example, if I use the set Joe, and within the quotation marks and obnoxious full, so this will set the values this keyword to the value to the expression or to the variable Joe. So whenever I write Joe will be written with this expression. Okay, now multiple assignment of the several symbol are allowed in Mathematica just by equal sign. So a equal to b equal to c equal to d is equal to pi 4. So all variable are equal. So variable name are a, b, c, and d, and which takes the values pi raised to power 4. So when I say n numerical values of, let us say, for example, I want to have the numerical values of b. So numerical values of b, as I said, n is used to get the numerical values. So n with the b will give you the values this. Okay, so this is actually the numerical values of this one. So pi raised to power I is actually a complex number, and this complex number has this values. Now, whenever you work in Mathematica, when you start working in Mathematica, you will see that there is actually we always don't work on single file. We always work on multiple file. For example, one calculation can be used in one notebook file, another calculation can be used in another notebook file, and all this notebook file, whenever you define any symbol, all these symbols have a actually tendency to carry forward to another Mathematica notebook session. So whenever you start any Mathematica session, every notebook and every variable in each of this notebook has the same values. For example, you may define another you may write or you may create another Mathematica notebook file where there will be a symbol a. So whenever you use this symbol a in another notebook file, in this current session, Mathematica will use these values of the values of a, and in this way we are prone to get the error, because mistakenly we don't want such kind of things to happen. We may want that a should be different values than the previously defined values a, or we may we may want to have a as a variable, but since in other notebook a is having the values, a has already defined values. So to get rid of all those things, whenever you start any calculation, it is better to clear all those variable from the Mathematica memory. So there is a way to clear all those memory previously defined variable or symbols in Mathematica with the command clear. So when I use the clear within the bracket a, b, c, d, that means Now onwards, whenever I use any calculation starting with A, B, C, or D, this keyword will be actually used as a symbol, not as a named symbol or a previously defined variable. So this will be now taken as a symbols. Okay, and we can all clear all the things at the same time, so with the help of clear all global. So clear all global means you want to get all the symbols defined, clear all the memory which is previously defined. Okay, so these are all the things. Now whenever we come to the next thing is that arithmetical notation. So there are inbuilt defined functions, inbuilt defined symbols in Mathematica. For example, plus, minus, underscore, negative, subtraction, and so on, divisions, power operator, and so on. So there are actually way to get all those input. For example, negation, negation is with a negative sign. So minus a will be give you negation. Similarly, minus is also used for subtraction. So a minus b is used for subtraction. And in the function form, there is a corresponding function form of the that expression. Function form means Mathematica defined function which actually works with the same purpose. For example, times -1 comma a will give you the expression minus a. So this is actually function form of the algebraic input like this. Okay, so there is a function form of this and there is a notational form of this one. So these are all the arithmetic notation we use in our day-to-day computation one. Okay, so factorial is also there in the, so all these things can be used or can be done with your keyboard only. So for example, if you want to have the b bth square root of a, then you can use it as a raised to power 1 by b, and this can be defined in the Mathematica input by use of the keyboard only. Okay, for example, a star b will give you the multiplication sign, a divided by b will give you the division sign. Okay, now whenever you have a multiple kind of operations, then order of precedence will be first there will be exponential calculation, then division one, then a star, then plus, and then minus. So these are all precedents which is followed in Mathematica as per your mathematical convention. Okay, now in Mathematica, there are some delimiters, that is some parentheses, which is actually commonly used. And these are only allowed in Mathematica. So you are not allowed to use all these parentheses in others contexts. For example, parenthesis is used for grouping of the algebraic expressions. So whenever you want to group certain thing, you are allowed to use only the small braces. Now this capital square bracket is only used in the brackets. This is a bracket, but its use is function argument. So whenever you want to assign any functions with some argument, you have to use this one. And the curly braces is used to get the matrix or list or vectors. So this means that you are not allowed to use this parenthesis, small parenthesis in the function argument, and also this one. So all these things has only this kind of operations, and you are not allowed to mix all these things. Okay, you cannot use this square bracket for grouping. Similarly, you cannot use a square bracket for list definition. Okay, now double square root double bracket, double square bracket is used to get the part of expression. That is, if you want to extract certain portion of the list or certain portion of the matrices, then this double bracket is used. Similarly, comma is used to get separate the elements in any list or matrices, and semicolon is used to separate some expression. So whenever you want to have several expression in a line and you want to separate all this expression, then you should use the semicolon. And semicolon also has another use, that is used to suppress the output. So this is also work as a suppression of output. But if you want to separate the expression in any in a single line, you have to separate by with a semicolon. Then text string is used with a double quote, with a double quote. And whenever you want to comment anything in any kind of expression, then you can use with a small braces followed by a star. So all these things can be used. For example, 2 plus 2 star into, so this expression is followed with the order of parentheses, and its values is 41.5. So these are all the things. As I've already said, square bracket is used only for the functional argument. So you are not allowed to use the square bracket for others things. Okay, comment, you can use it. Similarly, I said that whenever you want to separate any expression, you can separate it with a semicolon. And semicolon has another purpose, that it separates the output. That is, for example, if you want C is equal to A star into B into B star into 12, and this A and B are already defined, that is A is 2 and B is 3. So this expression will be evaluated, but since it is followed by a semicolon, so its value will not be printed out in your notebook, in your front end. But if you want to display it, just write C, and with the and enter it, its value, whatever its value is there, it will be printed one. It will get printed. Okay, so these are the things which is important one. Okay, one important thing about Mathematica is that whenever you use the exact symbols for any number or any others function, Mathematica will try to do any every calculation with the exact form. For example, 1 by 2 is expression. It is actually a rational expression. So its value, or it will be shown as 1 by 2 in every calculation, whatever you followed after this expression. For example, e raised power pi is again a number, a symbolic number with its value with value e raised power pi, but its value will not be printed. Whenever you use this expression in any mathematical calculation, its value will be taken as e raised power pi only, that is in symbolic form only. But if you want to get its numerical value, then you can use it, the n expression. So when I use n within the bracket, this e raised power pi, then its value will be shown to you. Otherwise, every calculation, unless you don't specify this n or any other things, then Mathematica will always try to do every calculation in this format only, in this symbolic format only. So Mathematica will try to get the calculation or get the result as means as accurate as possible. Okay, for example, 8 factorial raised power 2 with 13 raised power divided by 13 raised power 9, it will give you the expression like this. Okay, so anytime if you want any numerical expression, then you can use the variable n or function n to get its numerical approximation. There is another form, that is scientific form, which is actually used to get the scientific notation of any number, so that you can find in the Mathematica help. Now, substitution. So substitution is another important thing about Mathematica. You have to be actually use it more often. You have you are using more often in any mathematical calculation. So for example, quadratic was already defined expression in the Mathematica. For example, if I write quadratic, what was the quadratic? Quadratic was a symbolic expression. Okay, it was a symbolic expression. I think quadratic I have not defined. I have not run it, so that's why it is not giving the answer. So let me run it. So quadratic is now expression having these values. Okay, so now whenever I will use the quadratic, unless we don't clear the memory. So quadratic, when I run now, the quadratic expression will be now c plus b x plus ax square. Again, you can see that I have cleared the memory ABC earlier. This memory has been cleared. So its value, its quadratic value is ax square plus bx plus c. But if you want to get the values of this quadratic expression with the symbol A replaced by 1, B replaced by 2, and C replaced by 3. So this is actually a temporary assignment. Okay, we don't want to interfere with the quadratic expression, but we simply want the values of the quadratic function, which is defined earlier, with the values with the parameter A equal to 1, B is equal to 2, and C is equal to 3. Then its value can be calculated by this expression. So whenever you do this operation, the Mathematica will display its value as 3 plus 2x plus x squared, meaning that it's simply a replacement one, but this replacement is temporary one. Okay, it doesn't change the value of the expression quadratic permanently by replacing A is equal to 1, B is equal to 2, and C is equal to 3. So this is sometimes very, very useful. When we don't want the parameter to get changed, only want the parameter should be replaced by this one for the particular context only. So this kind of temporary assignment is sometimes useful. Okay. Now, let us define some list. List means it can be a vector, it can be expressions, it can be a matrix as well. So basic syntax for list is so range is another function. Range is basically a Mathematica built-in function which produces list of integers starting from 1 till the number n. So range n will always produce a list of integer from 1 to n. So when I say a list, when I assign a list range 10 to the a list, that means a list will be a list. It means it is a vector. It is also is a vector. It is also work as a vector. So it's a vector having the entries 1, 2, 3 till 10. Similarly, you can have the matrix as well. So matrix definition is actually done with the help of double curly braces. So first curly braces is for the outer one, and the second one starting with the interior one. So this is your first vector, first row, then this is your second row, and this is your third row. Okay, so this is how you can define a matrix with each with row by row. Okay, so within the first row you have to separate it by semicolon, colon, then second row, then followed by colon, and then third row. So this is how you can create a matrix in Mathematica. So this is a Mathematica definition. Matrix definition is Mathematica. This is actually a row one. It is a list one, or it is a vector one, or you can say it is a row vector, row matrix. Okay, so reverse list. A reverse is a Mathematica built-in command which try to reverse the order of the numbers which is there. Transpose is again a Mathematica function which is used to get the transpose of the matrix, any matrix. Now this matrix notation, it is a textual form. So this is actually used when you don't have any palette command. Whenever you using online version of Mathematica, then this matrix representation is actually useful. But there is always a natural math notation of this kind of matrix one, and that you can use it by that can be get by the function matrix form. So matrix form is actually a function which is used to get the natural math notation of the matrix of previously defined matrix. Okay, so for example, a matrix was defined in a textual form like this. So this is a matrix, so which is having the 3 rows. Okay, and this matrix can be displayed in a matrix form. So this is your matrix form of this matrix. So 1 4 7 2 5 8 3 6 9 is your rows. Okay, so this, let us say, for example, if I define test variable with this given matrix, so this will be defined. This matrix will be assigned to the test. Then if I want to get the transpose, now this kind of matrix definition, sometimes whenever you use this matrix form, this is not a proper mathematical input in Mathematica. Okay, for example, if I get the transpose of this test matrix, then you can see that transpose is not evaluated as such. It is displayed as such only. That means there is no calculation at all. So for this one, for this kind of situation, this matrix textual form is actually useful. Okay, so textual form, when I use a textual form A matrix, then transpose will be working with the A matrix, but not with the matrix form. For example, if I get the transpose of this matrix, then this is a transpose. This result is get displayed because A matrix is in the input form. But when you write this matrix form in this way, then this the result which you get is not in a Mathematica input form. So you have to convert this in an input form first, then only you can use it one. You can use it. Otherwise, it is not useful. It is useful for the displaying the output, but not for input the input of a matrix. Now, any of the list has some numbers, and each of this number or each of this row can be displayed with a certain command. For example, if you want to get some element, third element in the A list, then you can use it with a double bracket, double square bracket. So double square bracket is used to get the particular entries of a list or particular entries of from a matrix. So A list with 3 will give you the third number. A list, A matrix with the 2, 3 will give you the number which is the second row and third column. Second row and the third column. It is same as A2, 3. A matrix with a number 2 with the suffix 2, 3. Similarly, A31 is a 7. Now, if you want to get any particular row, that is, then there is another command which is A with a 3. So A with a 3 will give you the third row. Similarly, you can get the any column. So any column means I think column 3 will give you. Okay, we'll talk about later on this one. Okay, so A3 will give you the third column, third row. So similarly, this one is your particular element in a matrix. Now there is a small, there is some particular function which is called iterator. Iterator is actually used with a table. Table is actually one of the iterator in Mathematica, available iterator in Mathematica. So table actually used to get a series, series kind of things. So when I write table with x is starting from 1 to 11 with a spacing 2, that means it will give you displayed all the numbers starting with 1 with a common difference of 2 till 11. So it is a iterator. It is actually used in the a for loop. You can use in a for loop, or even you can use in a function iterator. Okay, for example, if you want to get the function value of basic function is starting with n, with the n is starting from 0 to 4, then this you can define it. So this will be give you in the this will be in the form of list. So you can use as a variable 2. So for example, you can use it as a variable 2. So for example, a series is a variable which will store the values of this kind of expression. So this will be stored. So A series will be storing this kind of list. Okay, apply is another kind of function which is very small, and you can use it. You can further get this value. So apply is actually whenever you want to apply a certain expression on a certain function with a certain range. So that kind of things can be used with the apply function. I suppose that this function, all this thing will be doing in a hands-on session in more elaborate form. So similarly, you can have arithmetic and algebraic relationship with a equal sign or unequal sign. Whenever you want to define equation, then you have double equal sign, then unequal sign. So all this kind of relation operator is used, can be used in Mathematica too. So for example, 2 star 2 equal to 2 square equal to 16. All these things can be used in Mathematica. So this is an expression which is true. Okay, so this is all this this expression is a true value because this is all this is evaluated to be true one. Okay, so this is actually a kind of relation operator which we can use it in many places. Okay, so now important thing about equation, just we said that there are some relation operator, for example equations, equal sign. So whenever you want, so one equal, single equal sign means assignment, and double equal sign means equation. Whenever we have equation, then double equal sign can be used in place of inequality. So equal sign, so when I use equation equal to this equal to, that means this equation has been named with the equation variable equation 1. So whenever I refer to equation 1, eq1, then we refer as this equations only. So equations, this equality is for used for assignment, and this equal sign, double equal sign, is used for equation. So this is a equation which is named with the variable eq1. Okay, so when I use eq1, then this expression, this equation will be referred. For example, if I want to solve this equation, then I have to simply write solve eq1 with variable x. So solve will be give you the solution of this equation. So this is a quadratic equation having two values. So x is -1 and x is 4. Now sometimes, and so this is a simple equation, so you can use it to get the solution of equation. But many a times we have certain equation, and those equation can be have to be manipulated further to get the equations. For example, let us say you have some kind of equation, for example, left hand side equal to right hand side. So that is the equation, left hand side equal to right hand side, and this is a simple equation. This is just a simple equation definition. So this is your equation, which is defined as eq1. Now whenever, if I want to get another equation, for example, let us say left hand side is square equal to right hand side. Okay, suppose I want to get another kind of equation from this equation, where the new equation will have a square of this equation. So square of this equation means left hand side square is equal to right hand side square. So in Mathematica, there is a way to tackle this kind of equation, this kind of things. For example, if I use EQ, simply EQ is square, then this will be you will get as a the result will be this one. But I'm not interested with this one. This is actually not the one which I want. I want another equation which is actually equal to which is actually left hand square is equal to right hand square. So that kind of thing can be used with the notation thread. Okay, so there is a inbuilt function in Mathematica which is called thread. So thread is actually used with the symbol this hash. I suppose you can see this symbol. So this is a hash command. So hash is actually a thread. Okay, and it is used with the AND operation, and followed by @equation. @equation means refer to equation 1. So in equation 1, okay, whatever the thread is there, you have to square it. Okay, so thread has a square and followed by and with eq1. That means this will be each of this expression, left hand side and right hand side, will be squared, and then it will be equated with the equal sign. So this is your equal sign. Okay, similarly you can use in this one also. So thread power eq square equal. So this is another kind of the same kind of technique, or same kind of result will be getting it from this expression as well. Okay, so one of the use of this one is actually is this equation. For example, let us say you have this equation. I have named this equation as a EQS is equal to this one. So this equation is a set of equation, different equations. So pi equal to P plus K, PE cos phi equal to PI and so on. So there are actually 1, 2, 3, 4 equations in this one. Suppose I want to get the solution of this equation in terms of variable PF, PE, K, and phi. Okay, keeping the other variable as a parameter. For example, theta is a parameter, theta can be parameter, and m is again a parameter. Okay, so if you want to get the equation solution of this kind of equation in Mathematica, simply using solve equation will not solve it purpose, because solve will give you solve with this command will give no answer, because Mathematica will not be able to find the solution of this expression without any external interference. Okay, what is actually way out of this kind of thing is that you have to simply, if I square this one, if you look at this equation, if I square this second and fourth equation and add it, then this equation is solvable. This equation is easily solvable. So this kind of suppose now this you have this equation and you want to square this equation first, second equation, and square this third equation, and you add it. So how this can be manipulated in Mathematica? There is a simple command. For example, let us say rename this equation as equation 1. So equation 1, in equation 2, this is your equation. So when I write this one, so this is a list. So list has a values. This is your first member, this is your second member, this is your third member, and this is your fourth member. So equations, since it is enclosed in a curly braces, so whenever I use a curly braces, I mean to say it is a list. For example, this here, when I write certain thing in a curly braces, it is a list. Okay, for example, this one, it is a list. Similarly, when I use a double curly braces, it is a matrix. So when I use a list, that means I have a list of equations, and I can refer each of this list equation with the help of the number or the expression equation 2. So equation 2 means second equation, equation 3 means third equation. So what I mean to say here, I want to get the second equation, a new equation, where new equation will be the square of the two equation, then the square of the two equation. So this will be a square of the two equation plus a square of the third equation. This is a third equation, and equated to 0. And then you have to simplify. Simplify will come later on. So simplify is simply a mathematical command to simplify the algebraic operations. Okay, so when you square the second equation and third equation and you add it, what is the remnant, or that is what the result is there, this is your result. Okay, now you have the equation set of equation. Now you have new equation. So new equation is your equation 1 together with equation 1 and equation 4. Okay, so this is now solvable. This equation, the new set of equation, is now solvable. So now Mathematica can easily solve this equation. Now, so see, by manipulating this equation, you can easily solve any kind of equation. So whatever the equation you have in Mathematica, if it is not solvable, then there is a manipulation. There is again exists a manipulation kind of equation where you can use it and then you solve this kind of equation. So otherwise, if you don't use it, you have to manually write this equation in a Mathematica, and then you can use it. Otherwise, you can use the Mathematica functions, built-in Mathematica function. For example, this function, third function. This is a third function to get this new equation out of your original equation. So these are all simple commands in Mathematica. Now let us come to some other important topic of Mathematica. For example, there are some inbuilt functions in Mathematica. There are so many inbuilt functions, but these are some of them. For example, gamma function, error function, Fresnel function, sine, cosine, Legendre, and all those functions are there. Okay, and all those functions are there in Mathematica. For example, exponential, logarithmic to the base b, trigonometric, then inverse trigonometric, hyperbolic, inverse hyperbolic, and so on. So there are so many functions, and the list is indefinite, infinite, almost infinite. Whenever there is another function, it is always automatically keep updated in Mathematica functions list. Okay, so let me come to another some other topic as well. So for example, plot command. Whenever you want to plot some function, you have to simply call the plot with the function name, function definition fx, and the range of the function, the range of the input variable in which you want the plot of those functions. So fx within the bracket x, starting from x minimum to x maximum, will give you the plot of this function. Okay, so this will be the plot of this function. Then you can always use another plot using some evaluation or some other function. For example, d stand for derivative, and fx is a function which was defined earlier. Okay, I think function was defined earlier. So function, just define this function as a d of arc sine function. Arc sine function means inverse sine function. So derivative of this function with respect to x. So fx is defined as a derivative of sine inverse x. And if you want to plot this for derivative function, so this is your plot of this derivative function. Similarly, you can evaluate, you can tabulate this sine 2x function starting from n is equal to 1 to 4. So table means it will evaluate this function starting from n is equal to 1 to 4, and you have a 4 set of functions. So these are the 4 set of function, and each the function is plotted in this form. So this is a plot of this function. I think there is a semicolon, so that's why it is plot was not displaying. So this is your plots. There is a 4 plot because there is a 4 expression in this tabular in this form. So table means you have a sine 2 pi x, then sine 4 pi x, and so on. Okay, this will come later on. Let me come to the next function and next thing, because we are running out of time. So let me come to second section, which is about functions. So there is so many ways to define a Mathematica function in Mathematica. So there is a one kind of function which is called implicit function. So when we say implicit function, it is not a implicit function in usual mathematics. It is actually a definition like this. So whenever you define a function f is equal to x squared plus bx plus c, that means this is an implicit function in Mathematica. So this is actually one kind of definition of the function. So whenever I say this is actually with the help of equal sign, just equal sign. Okay, so this equal sign is whenever you see this one, this means it is a kind of implicit function definition in Mathematica. This function can be evaluated with a values of the parameter or and the variable. So for example, I can evaluate this function with the values a is equal to 1, b is equal to 2, c is equal to 3, and x is equal to 4. So its value will be there. Similarly, you can differentiate this function too, but this function, if I use this kind of evaluation, that is a is equal to 1, b is equal to 2, c is equal to 3, then the nature of the function will get distorted, and in this function the new function definition will be c3 plus 2x plus x squared, because a and b, a, b, c has been already replaced with certain values. Okay, so these are you must be careful about this thing. So this is actually a temporary assignment, as I have already discussed. So this is a temporary assignment, and this is a permanent assignment of the variable. So you must be careful about this kind of use. Okay, similarly, when I say x is equal to 4, then x will be actually defined in this, x will be replaced in this one, and now f is no longer a function, it is actually a variable now. Okay, it is actually a number now, because all the variable has been previously defined, and f was actually a function which is actually defined in terms of input function. So whenever you use this kind of things, you must be careful about this one, because the nature of the function get distorted. For example, if I want to get the derivative now, derivative of the function with respect to x, since the f is now no longer a actually a function. So there is no variable in this function itself. So it is actually pure, working as a pure number. So Mathematica will give you some kind of error. Okay, 4 is not a variable, valid variable, because it is actually x is also defined a 4, x is also defined 4, and f is also a number. So this is a kind of error. So to avoid this kind of error, you must clear the variable x, because unless you don't clear variable x, f will not be a function. So once you clear the variable x, f will be now a function. Again, in this function, the values of a, b, and c is already defined in this case. So to get the variable parameter as well, so you must clear variable a, b, c as well in from the expression. So if you clear all these things, let me define the function first. So this is a function, and the function value is this. Now clear ABC and then find the derivative. So this is now derivative of the function with the parameter ABC. Although we have used ABC, but since we have cleared the variable ABC, now the function is working as a with respect to variable x, and not only with respect to variable x, ABC is also a parameter in this one. Okay, so similarly, the g function can be defined in this case. Okay, so this is a kind of assignment operator which is used to define the function which is known as the implicit function. Okay, in this one, the parameter can also be defined as this one. So parameter can be given as this one. So whenever you use f with a slash dot one, that means f will be used, evaluated with the parameter which is defined in this one. So parameter is actually ABC, which is value 1, 2, 3. So this is your function definition. Now, there is another kind of definition of the function which is called the explicit function. So explicit function is actually used with the argument, with the definition, function definition within the variable, the function name g, with the within the square bracket x underscore. X underscore means x is a variable. Okay, x is a variable. All the variable is starting has a this kind of notation, that is x underscore. So x underscore equal to x square exponential x square. So this is a kind of a function definition which is known as an explicit function definition. So when I say gx, so gx means e raised power minus x square into x square. Gy, again, it's the same thing with the variable x is equal to y. Okay, similarly, you can find any variable, any value of the function by g of 2. So g of 2 will be this one. Okay, so this is there is another kind of function definition which is called delayed assignment. Okay, so one kind of assignment was left hand side equal to right hand side. That is, left hand side is actually usually a function name, and right hand side is an expression of the function. Now in the delayed assignment, we use left hand side colon equal to right hand side. So this is called a delayed assignment. Okay, so what is the difference between these two? Let us consider with example. For example, plot derivative. Plot derivative is actually a function. This is, we have given a name, plot derivative. So this take the argument f as an argument, and it takes f as a argument of the function. Not only f as an argument of the function, but also the variable x with x minimum and x minimum as a variable. Okay, so f is actually plot derivative is a function which takes the 4 argument actually, f, x, x min, x max. Okay, and this is a kind of delayed assignment. Okay, this is a delayed assignment. So delayed assignment is equal to plot of evaluate d of fx. D of fx means fx, which is we have already defined. Fx is a function which is already defined. So derivative of this function. Okay, now when I use this kind of definition, this is called delayed definition of the function. Okay, so this delayed of the you can use it later on. For example, AD function is inbuilt function. ADI is a inbuilt function. So this AD function is replaced with this argument, and X is X. X minimum is -10, X maximum is 4. So this is a this plot is working because it is a delayed ADAI. I think the first function is not defined. Okay. Anyway, ADAI we have to define it for this one, but I don't think we have this ADAI function. We have not used this ADAI function. That's why it is showing me this kind of things. So ADAI function, once we define ADAI function, then this plot will be get evaluated. So see, the difference in this one is that immediate assignment, this kind of immediate is appropriate whenever your right hand side provides an immediate result, and that can be delivered without further processing of left hand side. Okay, so whenever you use it, however, if our right hand side is more complicated, for example, here it is a complicated one because it first evaluate the derivative and then it evaluate this expression. So in this kind of operation, the delayed argument is used. Okay, whenever you want that this derivative should be calculated once we input the function. Once we input the function, then only this derivative will be calculated, otherwise will not be calculated. So in this kind of situation, whenever you want the delayed assignment, when you want to have a delayed assignment, because we don't want to get the derivative first, we want first fx to be assigned and then the derivative to be assigned. So in this kind of situation, this delayed kind of assignment for the function definition is useful. Otherwise, for the immediate cases, for the simpler cases, this kind of assignment in the function one is useful. Otherwise, in the more complicated one, whenever you want a nested kind of operation, whenever you want a nested kind of function definition, then this kind of delayed operation will be used. Otherwise, this you will fall in a problem. So it is always advisable to get a delayed kind of assignment in case of a function. You always try to get the delayed kind of function, because delayed kind is more versatile. It is used widely in the form of function definition. Now, this is a kind of single function, single variable function, but if you want to get multiple valued, for example, you can define a multiple function. For example, I can define a function having two argument. Two argument means x and y. Then this can be also defined as such, equal to x squared plus y squared. So this is a multivariable function. So similarly, you can define other variable function. Okay, so this is a single variable and this is a multivariable function. Okay, so for example, this is a multivariable function because this is a function having so many variable. F is a variable of a, b, c, and d. Okay, so all these variable is occurring in the right hand side. Okay, so this is a function one. Now, many times we have a definition of a function like in this one. For example, let us say if I want to define a function like that, we'll take one example here. Suppose we have a problem of finding the function, finding the coefficient of x raised power. Suppose I want to determine the coefficient of x raised power 1 in the expression a plus b x raised power m. Okay, if I want to get the coefficient of x raised power n in this function 1, in this kind of expression, then this kind of problem can be tackled in Mathematica very efficiently with the use of this command sequences of the function definition. So function argument is equal to delayed argument, and delayed argument equal to expression 1, expression 2, and so on till output. Okay, so this means initial step return their output to the next. So this expression will return this whatever the output is there to the expression 2. Then expression 2 will return this output to the next one, and so on till the final output is displayed. For example, let us say I want to get the coefficient of x raised power n in this expression. So you can get it by simply defining this function. Let us say if this function is a function of n and m. Okay, so n stand for x is power n and m stand for this one. So this one is actually, suppose I define expression 1 as a temporary, expand this one. So first kind of expression is, first this will be expanded, this expression will be expanded. Okay, and once it is expanded, then in this temporary form of this one, coefficient of this expression x is power n in n can be calculated. So in the next one, this is your actually output. There is only one expression in this definition. So expression 1 is evaluated first, and this output is given to the expression or the output form, which is coefficient temporary x is power n. So this will give you the coefficient of power x is power n in the expression a plus b raised power 30. So this is your, so if you want to get what is the temporary, temporary is actually the expansion form, expanded form of the expression. So this is, for example, this one. Okay, so this is actually a command function form from the command sequences. Command sequences means you have a several sequences to be calculated, and finally the output one. Similarly, there is a kind of convention like pure function. Pure function is actually occurs whenever you solve the differential equation. So let me skip this one. Then there is a recursive function. Recursive function is, for example, in the factorial form. If you want to obtain the factorial of any notation, then there is a recursive function used there. So recursive function, it is actually simpler one. So let me skip this one also. So there are some something like the step function or piecewise continuous function. All these function can be defined with the simple definition one, simply writing the definition. So we'll talk about this one in our hands-on session. So we are skipping this one for the hands-on session. We'll talk about this one in a hands-on session. So let me for now come to algebra. So in algebraic one, I have a very short things to tell you. There are some predefined algebraic function for to get the things done. For example, together is used to get all algebraic function added or subtracted. That means with the same denominator. A part is used to get the partial fraction of the expression. Cancel is used to cancel out the sum expression from the function expression, and numerator and denominator is used to get the numerator and denominator of any expressions, and so on. Okay, similarly, expand numerator will be expanded. Expand denominator means denominator will be expanded, and so on. Expand function means this function will be expanded in the most simplest form. Expand all means it will be expanded all. Then there is a cancel command. Factor is used to factor all those things. Okay, suppose I want to factor this one, so this will be factor. This will be expanding, and this will be expansions expanded form. And if I write if you want to factor this, you will use the factor form and will get this one. Okay, so factor is used to get the factor of this one. So just like this one, collect is actually simply used to get the terms collected together of the like powers. Okay, so this is a very useful command to get all the expression of like powers of x together. So this is a collect command. So factor terms and so on. So all these are algebraic manipulation. You can do it. Similarly, there is a corresponding trigonometric expression. So trigonometric one is actually has a similar kind of calculation. So trigonometric expand, trigonometric factor, trigonometric reduce, and so on. These are all trigonometric related algebraic manipulations. This one is simple kind of thing, so I'm not devoting much time over this one. So simply you can use this one in whatever you have in the expression. Okay, so this is algebra. Then complex variable, again this is a short discussion. So simply there is a simple number which is called iota. Okay, so in iota, whenever you want to define a complex variable, you simply write x is equal to I plus eta y. Eta, either it would be, this is a symbol one. It is coming from palette, but there is a expression, there is a keyboard expression. I have already told you that capital I used to get the complex unit. So complex unit is this one, either this one or the capital eta. Okay, so this is your z, and if you want to that if you want to get the all these expressions, sine z, cosine of z square, log of z, what will be this expression? And if you want to complex expand, then this is your expanded form of this kind of expression. So all these things can be used to get so there is a built-in command, real part, imaginary part, absolute and conjugate command, which is used simply use it to get all these things, all the calculation in the complex plane. Okay, conjugate is there and so on. So this is also a small topic which I again you can use it. Then comes the important thing about calculus. So calculus we only talk about derivative and partial derivative and integral. So partial derivative, d partial derivative actually denoted by d with within the bracket f and x. So again, I have already told you that d is actually a predefined keyword. So you are not allowed to use this d function or d variable as a another function or another variable name. So this is defined, defined. So when I use d, capital D, it is actually a partial derivative with of function with respect to x. So if you have so many derivative, so many function in this one, so in that case you can use it. So for example, d of fx will be del fx by del x. If it is a single variable function, it will be a total derivative, otherwise it will be a simply partial derivative. Similarly, d of fx any power and another derivative is actually defined by this expression. Then if you have a function of two variable, then comes the partial derivative notion. So d of fxy with respect to x and y means del square f with respect to x and y. X with respect to x and y means it will be a double order derivative. So del square f del x del y. If you want to get the derivative of this function fxy, partial derivative order of x will be n and partial derivative order of y will be m, then this will be given by this particular derivative. So this is actually used to get either a derivative, simple derivative. If it is a first order derivative, first order function, then it will be a simple derivative. Otherwise, it will give you a partial order derivative. So these are the simple expressions, simple function used to get the derivative of the either derivative or partial order derivative. So that's it. And there is a way to express the derivative. For example, there is another definition, delta. Delta is also sometimes used. This is also a predefined function in Mathematica, and this is actually occurs in a palette command. So this D is in your from your keyword, or it is also occurs in palette, but this delta is there in your palette one. So delta is also used sometimes. So whenever I say delta x comma n, that means partial order derivative of f with respect to n with respect to x will be n, and partial derivative of f with respect to y will be m. So this will be derivative of this function. Similarly, if x is a simple first order function, one variable function, then this is actually a double derivative. This is a fourth order derivative. This is again a fourth order derivative. So this is all the symbol and all the variable. For example, all the simple mathematical expression can be used here in the form in the derivative. For example, I can use the product function to get the derivative. Derivative of the product function can be get by this one expression. So this function, I mean to say that this function is not a simple function, but can be a more complex function, or it can be expression too, and that can be that Mathematica can give you the derivative of expressions, function, or complex functions too. Okay, so the for example, derivative of integral. Derivative of integral, you know that it is a, these are all inverse of each other. So they cancel out. So this is actually a function one. So this one is there. Now in the derivative, there is important options available to you. So sometimes the function can have some kind of parameter or variable, and in that function list, in that parameter or function list, you sometimes you can get you can define the constant, which are the constant and which are the variable. So let us say, for example, if I define a function f of xt, and I want to get the derivative with respect to t, and the function in that case, the non-constant variable is x. So non-constant variable is x means the Mathematica will take care of this one. Okay, Mathematica will take care of this thing as well. Not only this, you can also use the constant one. What are the constant one and that too? Okay, so Jacobian can also be defined in the Mathematica as well. So for that, we need to have another kind of definition. For example, D can be used to define the Jacobian as well. Okay, so we'll talk about this one in later in a hands-on. Okay, so this derivative function dt is another kind of derivative function which is defined in Mathematica, which is used to get the total derivative. So dt means it is a total derivative. Simple d means it is a partial derivative. So and dt means total derivative, that is df by dx. So df by dx, you can get it by this way, dt. So dt means dt of f of xt with respect to x. Okay, so this is your dt. Now in dt, total derivative, you can specify which are the constant. So in this case, for example, let me consider this example. If I define this function dt, partial derivative, total derivative, then there are actually 4 variables. Okay, x, y, z, and t. So Mathematica will not be assigning any of the variable to constant. Instead, they will specify that derivative is there, this derivative. So first, this is your derivative of this function with respect to first variable, derivative of this function with respect to second variable, and so on. Unless you don't specify which are the constant and which are the variable, Mathematica will try to keep all this thing in line with the definition of the derivative. But once you define that, let us say in this expression, the constants are x and y, then Mathematica will automatically assign this function, this derivative, and will try to give you the answer in such a way that the constant will fall as a x and y. So once the constant is there, then Mathematica will give you the derivative in the required form. Okay, so this is about derivative. Then for example, derivative can be used to find maxima minima. So there is a function called find maximum minima or find maxima, which is there. You can find it maxima and minima of the function. Similarly, you can graph it and so on. Then Taylor series. Okay, so Taylor series is another kind of symbolic expression. So when you want to get the Taylor series expansion about the point x is equal to x naught, then the corresponding function, Mathematica function, is series f with respect to x naught, and n is the highest power which is retained in the series. So till power n, this series will be displayed. So for example, this is a function. If I want to get the Taylor series expansion of this function with respect to r, around r naught till r is power 4. So this is your Taylor series expansion of the corresponding function. So this is a Taylor series expansion. Then next thing is multivariable power series. You can similarly define a series f and so on. So that will be multivariable series. Now integration. So Mathematica support 2 kind of integration depending upon whether it is a indefinite integral or a definite integral. So the indefinite integral is expressed in this form, and definite integral in this form. So Mathematica has 2 kind of integral. One is, let me give you. So this expression is there in your palette. Otherwise, corresponding command of this one is integrate. So integrate and the variable x. Okay, so this is your indefinite integral. But if you want to have the definite integral, then definite integral can be found out by this one. So this is a definite integral, kind of definite integral, but in this case you take the values starting from x naught till, so this will be a definite integral. For example, the integral of x raised to the power n, and x is starting from 0 to 1. Okay, so integrate. This is your textual form of input. Okay, and this is a symbolic form of input. This input you can get it from palette command, palette window, and other textual form is there, which is always there for you. Okay, so this is a definite integral. So integral, these are simple things, so you can use it later on. Okay, so again, this is simple integral and derivative, but there are others. Multiple derivative can be also possible in the Mathematica. For example, you can have the two variable function, and you can integrate with respect to x as well as respect to y within the range x min to x max and y min to y max. So this is a multiple integral. Okay, so multiple integral can also be used in Mathematica. Uh, this is, by the way, your definite integral, but indefinite integral can also be used here. So indefinite integral means integrate x y squared with respect to variable x and with respect to variable y. So that is your indefinite, and this is your definite integral. Okay, so not only this one, more advanced integral like line integral, contour integral, and so on can also be done in Mathematica 2 with quite efficiently. Okay, so that I'm leaving to you to explore all these things in the integral one. Then let us come to the plot. Okay, so plot, there are so many plot command here, and if I want to explicitly discuss each of this thing, this whole Mathematica system that I have taken will be not enough for this one. So I will simply use a simple plot command here. So plot means a simple plot command is there, which is used to get the simple plot of y function, any function which is a function of x within the range x min to x max. Okay, similarly, if you have a list of variable or list of the function, list of the points, for example, then list plot is there to, and this will give you a plot of this one. Similarly, there is another plot command which is called parametric plot. Parametric plot means there is a parameter into it. So this is a two-dimensional plot. When I say there is no number, that means it is a two-dimensional plot. So plot is a two-dimensional plot, list plot is a two-dimensional plot, parametric plot is also a two-dimensional plot. So two-dimension means there will be two variable which will each depend upon the variable t, and starting with the parameter t min to t max. So this is a parametric plot, that is y versus x. Similarly, there is a density plot, contour plot, and so on. List density plot, list contour plot, and so on. So the list is so vast that we cannot cover it in a single class. Similarly, if you want to have a three-dimensional plot, there is a corresponding three-dimensional plot, that is plot 3D. So in this plot 3D, you have to have a two-dimensional function. So z will be a two-dimensional function of two dimension, x and y. So x will have a certain range, again y will have a certain range. So this is a three-dimensional plot of a corresponding plot. So plot is a two-dimension, whereas plot 3D is a three-dimensional plot. Similarly, parametric plot, there is a corresponding parametric plot 3D, which is used to get a three-dimension parametric plot. Okay, so x, y, z, three-dimension, three individual function depending upon a single parameter t. Similarly, there is a list plot 3D, okay, to get the plot of the list in the three dimension. Okay, and there are so many options to load it, graphics 3D, and so on. This one. Okay, so for example, as I've said, there are so many plot, and the list is indefinite: array plot, contour plot, list contour plot, max plot, and so on. There are so many things which is there in the plot one. Okay, so depending upon which one is to use, you have to use it. So for example, if a simple plot command, there is a r cosine, that is cos inverse function, is starting from x with the variable x starting from 1 to 10. Okay, so that will be giving you a plot. Then plot of cos kx, since k is not defined, so it will not be giving you plot. So plot actually uh, mm, assumes that all the variable and all the input are previously defined. So since k is not defined, so it will give you the error. Okay, similarly cos pi x, pi is defined, so pi there is no problem at all. Now k is, let us say, define k is equal to pi, so then plot will be shown to you. So this function, this plot, all this plot actually take care of the function defined earlier, whether in form of inline function or implicit function or explicit function. So every kind of function is can be taken as an argument of this plot command. So for example, I can define a fx function as a x cosine of pi x, and then I can plot it. So this is there. Similarly, you can plot it. We'll talk about this differential equation later on. Similarly, you can have the list plot. List plot means list plotting function list. Function list means you have so many functions. So you can separate each of this function within this curly braces. For example, logarithm function 1, logarithm function 2, and so on, x starting in the range 0 to 10. So this is a kind of, this is a technique to get all the plot together. So plot 1, plot 2, function 1, function 2, function 3, all plotted together. Okay, so this is a function kind of plot, function plot which is plotted together. So legendary function starting from 0 order to 10 order, all is plotted in the same command, same plot window. So there are some other option in the plot command. For example, you can put legend, you can have this ticks on the axis, you can have the plot range, in which range you want to have. Then there are some plot option which can be used. For example, the plot option is aspect ratio, axis, whether you want to get the axis or not, axis label, whether you want to label the axis as a x-axis or y-axis. So all these in optional plot argument can be used to further edit your plot one or further beautify your plots as per your requirement. So all these things can be done in this one. Not only this, you can also right click this this plot. So you can there is also option to get, I think I don't know, it is not showing here. So here there is option, so you can use it level. You can
I think the screen is not shared. Can you?
Mathematica indefinitely actually shut down.
Okay.
Let me reopen it.
Yeah, it's visible now.
Okay, so I was discussing about the plot. So as I said, there are so many options that you can use it. Okay, like this one. So aspect ratio, all these things are there. You can use it depending upon which plot you want to have. For example, one of the plot option I have used here, plot level and axis level. So axis level means I want to label the axis as a x, x-axis as a x and y-axis is a gamma x. So I want to get the gamma plot x, gamma plot of gamma function within the range of -5 to 5, and I want to label the function axis as a x-axis and gamma function. So this is your gamma function which is there, and the plot label, that is a whole graph will be labeled as a gamma function. So this is your actually the plot with the given plot option. Okay, so like this there are various options here. Plot frame label. So for in this case, if you want to get the frame of the plot, okay, suppose I want the frame. So there is a frame here. Frame means the outside border of the function will be plotted, and you have the option like this. You can also use the grid lines and so on. So there are so many plot options. You can customize this plot depending upon your choices, depending upon your work. Then there is a thickness one, absolute one, and so on. There's various commands. I cannot actually finish all these things. And all these things cannot be taught in a by a instructor. You have to somehow you have to use your own mm, way of learning all these things, and this cannot be learned in a single class. You can go on learning each and each every section one by one or day by day, depending upon your work. Okay, let us now come to the small section which is based on the differential equation. So how many time I have how much time I have? I think
Sir, you are it's still 1:30. You are having approx 1 hour.
okay.
Yeah.
Okay, so I can start this lecture on differential equation with the hands-on.
Okay.
Okay, so I request every participant to open their Mathematica online and do all this one in your Mathematica itself. That means try to get all this calculation done. So see, Mathematica, this numerical solution of this differential equation, not only numerical solution, but this symbolic numerical symbolic differential equation solver will also give you flavor of all the topic that we have already discussed. Okay, so all these things can be clubbed together because here is a assignment operator, there can be a simple differential equation solver and so on. Okay, so this can be done in this hands-on session only. So let us begin. I hope everyone is ready with their Mathematica online. So let me open my window and tell you how to do it. So you open a web browser. Okay, so first thing you have to do it, you go to Mathematica online. Mathematica, I think it's a Wolfram Cloud. Just open it, and this will give you a live version of Mathematica in your computer where you can interact it. When you open it, this will be your window. Okay, so in this window you can see it. There's some file which I have already created it. Okay, there are some file, and if you start afresh, you will see these two things. Either you can have this notebook, new notebook. New notebook means it will create an online version of notebook. So if I write it new notebook, then it will be the Mathematica is now ready with all the inputs. So for example, if I use it, if I add it, these two number, Mathematica will give me the result. Can you see properly? Everyone can see my...
Yes, sir. Yes, sir. It's very visible.
So for example, 100 factorial, this is your 100 factorial. Okay, so every calculation is now getting live calculation there. Okay, from the Wolfram Cloud. So let me start my session. So for example, let us me define first of all one differential equation. Okay, so solve one is one differential equation name which I have given it, and I want to solve this differential equation. Differential equation is in x double dash. X double dash, as you know, it means double derivative. X double dash t equal to means this is a differential equation. So equation means always have a double equal sign. So double equal sign means equality sign. Minus, so textual form, this is actually a subscript sub superscript. So this means that it is a W not a square. Okay, W not a square means, so this means this is a W not. So in textual form, see, Mathematica online version doesn't support so many things. One thing is that you cannot use palette command, that is you cannot use the integral sign and then derivative sign, and so on. So there are so many things you cannot use it. So you have to get the textual form of that kind of notation. So subscript, sub superscript W02 means W not squared. So 0 stand for 0 is your subscript and 2 for subscript. And this one, so this is actually, this differential equation is actually a equation. If I write x double dash.
Sir, are you writing something? Because the writing portion is not visible, I suppose.
Is it not visible? Okay, so I have
whatever you are writing, it's not visible, I suppose.
Okay, let me share my whole screen, then only it will be visual. Okay, so I wanted to show that this particular this particular keyword stands for W naught square. Okay, I think it is visible now.
Yes, sir.
Okay, and this whole equation means that I am writing this differential equation. This is your differential equation. X dash x double dash t is equal to minus W naught square xt. This is your equation. Okay, so I want to solve this equation. So the definition of the equation in the dsolve. So dsolve is a command. Dsolve is a differential equation solver in Mathematica. Okay, so dsolve is a function, inbuilt function. So it argument has to be in the square bracket like this. Okay, and in this argument, in this whole argument, you have to write the equation. So first I have written the equation. So this is your equation which is written in Mathematica. X double dash t equal to minus W naught square into xt. Okay, now next thing is that you have to specify the dependent variable and independent variable in this difference equation. So in this differential equation, what are the dependent variable? X is a dependent variable. So this is your dependent variable, and t is the independent variable. So you have to specify the t followed by t. So last one is your independent variable and the first one is your independent variable. This is also actually clear from the definition because I'm writing xt. So when I write xt, x is your dependent variable and t is your independent variable. But in Mathematica, you have to specifically specify what are the independent variable and what are the dependent variable. Okay, so this is your definition of this is actually the definition of the equation and the solver command in Mathematica. So let me now run it. So this Mathematica, actually this solve one is just a name. This is a name which is actually given to this solver command. So whenever this solve command, dsolve command is ready with the solution will be get input, will be get stored in solve one. So let me first solve this one. Okay, so see, Mathematica has given you a solution and this is in a pure function form. So this function is actually, it tells you that this output tells you that the function x is a function, tells you that x is a function of t. So xt is equal to c1 sine of t omega naught square plus c2 cos t omega naught square. So Mathematica has a Mathematica always try to give you the solution when you use this x followed by t. Mathematica will give you the output in pure function. Okay, now let me get another form of this same solution. So let me take this one and specify that x is a function. Now I'm specifying the this solver that give me the solution in such a way that xt will be a function of t. Okay, xt will be a function of t. So in this case, Mathematica will give you the solution in the form of xt. Okay, the same the output is same. Only thing is that the expression of the function. So in this form, the function has, Mathematica has given you the solution in the form of pure function, and in this case, the Mathematica have given you in the conventional equation form, solution form. So xt is equal to c1 sine t omega square t. So they both are the same thing. Okay. So when you use xt, the function will be in the most proper form. But if you forget to specify t, x followed by dependent variable followed by this t, then Mathematica will give you the in the form pure function form. Okay, so this is how you can get the solution of this differential equation. So it is it can be anything. This equation can be second order, third order, or a list of equation. Any equation like this can be solved by Mathematica. So let me now come to another example. Let me take another example of this kind. So as I have said, so this is a symbolic solver. Let me take another equation. D solve x double dash t plus 5x dash t plus 6xt equal to 10 sine t, and xt followed by the dependent variable and followed by independent variable. So again, the solution of this function will be c1 e raised power minus 3t, c2 e raised power minus 2t minus this one. Okay, this is your solution of this function, this solution. You can get the solution of the system of equation 2. So this is a single equation. You can get the solution of the system of equation 2. So x dash t equal to some equation, y dash t is equal to some equation. And now since there are two independent dependent variables, so both depending upon t, so you have to write in the braces xt, yt, and t. So in this case, the solution will be in the form of xt is equal to c1 e raised power 3t cos 4t, c2 e raised power 3t sin t, and yt is equal to this. So this is your solution of the equation. Now the same thing, let me take some another function, some another equation, some complex equation. Let us say this is a very, very complex equation. So this is your equation like x dash t is equal to a square root of sine of xt. Okay, and y dash t is equal to yt, and z dash t is equal to minus zt. So see, this function is highly nonlinear one. Okay, it is highly nonlinear. So it is very difficult to solve such kind of equation. So let us see if Mathematica can give this answer or not. Okay, so it is a very, very handy software, and Mathematica has come up with the answer. Okay, so this is the answer you cannot think of, otherwise you cannot think of this kind of equation. Mathematica has given you the function, the solution in the form of some function. This is a solution which occurs in the form of Jacobi amplitude function. Okay, so Jacobi amplitude function of this xt is this one, yt is this, and zt is equal to this. Okay, so this is a solution of the equation. Okay, now see, this is all about the ordinary differential equation. So can we solve the partial differential equation? Yes, why not? In Mathematica, you will see that there is only one command, dsolve, which is used to solve ordinary differential equation, partial differential equation, differential algebraic equation, even delay differential equation. Every differential equation of any kind, partial or ordered differential algebraic, there is only one solver, only one symbolic solver, I mean to say symbolic solver, which is called dsolve. Okay, which can be used to solve all the differential equation of any kind. Okay, so let me now imply dsolve to get the partial differential equation, solution of partial differential equation. So let us say we have a partial differential equation. So first I have denoted this partial differential equation. This is a partial differential equation. What do you mean partial? Since I have already talked about operator, what do you mean by operator? So duxt. So uxt is a function. Let me clarify. So this is this differential equation. This partial differential equation stands for del u is a variable, u is a function of xt by del square. T is 2, so del square, del t square equal to, this stands for del square u, of course xt, del square, del x square. So this differential equation, this partial differential equation stands for del square uxt by del t square and del square uxt by del x square. So I have named this equation as a equation eqn. Okay, now in the next line, the solution structure is there, the solution solver calling is there, dsolve equation, that means this is your equation, and what is the dependent variable? Dependent variable is uxt, and what is the independent variable? Independent variable are 2, because this is a partial differential equation. So x and t are two partial, two independent variable, and therefore this is a partial differential equation. So this, the same solver which was used to get the solution of ordinary differential equation can be used to get the solution of partial differential equation. So uxt is equal to C1. So you know that the solution of that function, that equation was, solution of this equation is uxt f1 of x minus t, t minus x, and f2 of t plus x. So when you solve this partial equation, because this is a wave equation, the wave equation has this particular solution. So this is also the same solution which as Mathematica has given. So Mathematica has given you the solution as uxt is equal to C1 of t minus x. As I have said that C is a reserved keyword. You cannot use this keyword C as a other variable name. So C is stand for constant actually in the constant of integration. Not only constant of integration, but also in a partial differential equation also, the function, arbitrary function is named with a C1, C2. So C1 means some function of t minus x plus C2 of t plus x. So this is a function form of this solution. So this is what the Mathematica actually Mathematica how Mathematica DSolve is giving you the solution of not only the ordinary differential equation but also the partial order differential equation too. Okay, so DSolve, this DSolve command is actually a versatile solver. Okay, if I go to help file of this DSolve, it has so many options. Okay, DSolve can be used to get one equation. You have a partial difference. You have a you can solve a differential equation between two x mean and x max. X mean and x max means it is actually a boundary value problem. Okay, so this is a solution of with a list of differential equation. I think it is visible properly. If not, then this is it. So this is a DSolve which is used to solve a differential equation between x mean and x max. DSolve can also be used to solve a variety of equation, different type of list of differential equation with a variable u1, u2. Similarly, you can have a partial differential equation, and not only partial differential equation, you can also use the partial differential within the certain region. That means you can also use this DSolve command to get the symbolic solution in some boundary value or some boundary region. Okay, so this was initial condition. This was a solution in initial in a boundary condition. This is actually a boundary condition. Okay, you can also get the solution of equation with some initial of some initial value problem. Let me take one example for that. So let me take one example. Let us say, for example, this one. So this is a initial value problem, a kind of initial value problem. Let me apply first, talk about DSolve. So DSolve is, no, it is actually a numerical solution. So only my only advice was discussion was about DSolve command. DSolve command is used to get the symbolic solution or closed form solution of any differential equation, whether it is a ODE or PD or algebraic differential equation. You can also get the same solution of some algebraic. Let me see any example is there in documentation center of DSolve. So there may be some example there. For example, this one is a initial value problem. This is a example of initial value problem that I was talking about. Y double x plus y x is equal to a sin x with initial value y0 is equal to y0. So this is a solution. Again, it is in a pure function form, but if you want to get the solution in the other function form, you can get it by simply replacing by y by yx. So this is your initial value problem, solution of initial value problem. Okay, so this is actually a differential equation. Let me get one algebraic equation first. There is no equation in algebraic one, I think. There is no example here, I think. Anyway, that can be solved. So that is only, I have said you, I have told you that dsolve is only command which is available in Mathematica, which can solve any kind of equation. So now let me come to numerical solution. Okay, so numerical solution, it means to say that you have some kind of numerically defined differential equation. Okay, so as far as dsolve is concerned, dsolve is used to get the closed form solution, or you can say analytical solution, you can say. Okay, but the corresponding, if any equation doesn't have any analytical solution or closed form solution, then your aim would be to get the numerical solution. So in Mathematica, there is a one command, there is only one command, just like dsolve. There is only one command, ndsolve, to get the numerical solution of all the ODE, PDE, or even DD, or even algebraic differential equation, whatever equation you think of. So there is only one command which is available in Mathematica, which is called ndsolve. Okay, so ndsolve is used to get the solution of the numerical equations, numerical differential equation. So for example, let me take one example. So this was a this is actually a boundary value problem, which I have already told you. So the syntax of the numerical solution, first of all, let me take the syntax. Syntax of the form takes the first argument should be equations, followed by fn, that is you can say what is called the state variable, state, not a state variable, that dependent variable, and then independent variable with a starting from minimum value to maximum value. So this is a ndsolve, particular typical ndsolve calling sequence. Okay, so every sequence has this kind of minimal calling sequence. Other options are optional argument that we can talk about later on. So this is your minimal argument which which ndsolve needs to get the solution of any differential equation. For example, let us say this equation, ndsolve theta dash double dash t equal to minus sine theta, and theta 0 is, since this is a theta is your you can say what is called dependent variable. It depends upon the parameter independent variable t. So theta value at 0 is equal to 3 pi by 4, theta dash 0 is equal to 0. So this is an initial value problem for this differential equations. Okay, so this is your differential equation. Okay, so this differential equation, if you and this is your theta, which is your dependent variable, as I have said, the equation followed by fn. Fn is stand for the dependent variable. So dependent variable is your theta, and then followed by your independent variable, starting from initial value 0 to final value of the independent parameter t. So this is your function definition for, or you can say the calling sequence for the numerical solution. Okay, so as far as dsolve and ndsolve is concerned, whereas dsolve give you the function form of solution, for example, the function form like this, but the ndsolve also gives the function form of the solution. Okay, otherwise if you compare with other solver, any numerical solution solver will always give you the numerical corresponding numerical form of the solution. But Mathematica is such a function, such a beautiful software, which try to give every solution in a function form. Okay, as much as possible. Okay, for example, this ndsolve is a solver which Mathematica gave the solution of this kind of equation in this form. So what is this form? This is actually an interpolating function. Interpolating function means it is an interpolating function of all the solution that they have got by solving this equation. You know that if you solve any differential equation numerically, okay, if I'm talking about numerically, let me explain something here. What is a numerical solution, first of all? So when I say numerical solution, I mean to say that every solution, every solver actually has a 2 steps. Every solver has a 2 steps to follow. Whether you talk about C or MATLAB or Maple or any kind of software, every solver has a 2 steps there to solve any kind of differential equation numerically. So first, what they will do, let us say differential equation is dy by dx is equal to fxy, okay, with initial value x naught is equal to x0. So the first step would be to discretize the interval in which you want the solution. So suppose I want the solution with initial value x naught is equal to x naught, and I want to go to x, I want to solve this differential equation in the range, here will be y at x naught is equal to y naught, and y will in the range x naught to x final, okay. So first step would be to discretize this interval. First step would be to discretize the interval x naught to x final, okay, in the discrete points. They will first discretize it, okay, and starting with x naught, they will try to determine the function value of the dependent variable at each of these points. So f of y at x naught, then y at x1, then y at x2, and so on. They will try to use different solution. That means second method would be to find out yn plus 1 from yn with some function of x and yn. Okay, so how they are using this, which method they will use actually depends upon method. So some Euler method will have a different form of f, Runge-Kutta method will have a different form of f, and so on. Okay, so depending upon the function, they will try to evaluate yn plus 1 from yn with this initial value. So the first step is discretization. Second step is to find the solution of all the succeeding points starting from x naught. So this is actually the whole principle in numerical solution. So Mathematica also had same kind of technique, that is they will start with this initial condition and they will try to evaluate all these points together. Okay, now once you have all these points, so that means let me talk about x naught with y naught, xn, yn, and so on. So now they have the points, all these points. Now what Mathematica will do further, they will interpolate all these points together to give you a functional form of the solution of this differential equation. So whenever the ND-solve is used, the solution that is there for this kind of differential equation in numerical form is actually expressed in this interpolating function form. So this is also same as a function. You can say that it is as good as a functional representation of the corresponding numerical solution. Okay, so this is actually the Mathematica form of giving you answer. Okay, so interpolating function is actually the interpreting data of all the domains, all the intermediate points which is Mathematica has determined in that one. Okay, so so it is actually now the next thing is that how to interpret this solution. Whenever you have a numerical solution, how to interpret this solution. So this interpretation and this numerical solution, since it is given you in the form of interpolating function, so next idea is to get this graph of this function, how to plot the graph of this function. So now comes the plotting command in application. So let me now try to plot this one. So as you know that this is a actually a kind of, when I say theta t, it is a kind of parametric function. So t is a parameter starting from the range, starting from the initial value 0 until its value till the value 10. So that means I'm when I want to plot this solution, I mean to say that it is a interpolating function. It is a kind of parametric plot. Okay, parametric plot where theta is a function which depends on the parameter. So here I will use the parametric plot. So parametric plot, and then there is a command which is called evaluate. Evaluate is actually used to get the evaluation of certain expression. For example, theta is a function which is actually available, which is actually coming from this expression. Okay, so unless you don't evaluate this theta at a certain particular point, you will not be able to get the function value. So see, plot function always use some values of the function. Okay, and that values of the function can be calculated by evaluate command. So evaluate, what evaluate will means evaluation of theta at a certain points. So evaluation of the theta. So in this case, there is a two plot I have used here. One is theta and theta dash t. Since this is a second order problem, so second order problem can be plotted in two dimension as a one variable as a theta and another variable as a theta dash. Okay, just same as a the initial value. So initial value of theta is given and initial value of theta dash is given. So in a two-dimension plot, the plot of this equation will be in the form of theta 0 and theta t and theta dash t. Okay, so this evaluation will be taken by the command evaluate command and then theta t and theta dash t. So this is a parameter. So it is a parameter. And there are two parametric equation. One parameter is theta t. One parametric equation is theta t. Parametric function is theta t, and another parameter is theta dash t. Okay. So this theta t and this theta t dash will be evaluated with reference. So this is actually dash slash nd solve 1. Nd solve 1 means it is actually coming from this solution. Okay, nd solve 1 is the solution has been named by this nd solve. So nd solve theta t means theta t is a functional form of nd solve 1. nd solve 1, since this is occurs in a index form, means list form. So if you want to get this function, this particular function, so you have to call by nd solve 1 within the square bracket 2 square bracket 1. So theta t will be coming from defined as this function coming from this one. So this theta t will be there. So theta t and theta dash t. Again, once you have theta, you can differentiate it to get theta dash t. So see, this is just occurring now. It is behaving as a symbolic equation, symbolic function. So you can not only use you can use theta, but also theta dash also you can use it. Okay. Otherwise, in other software, it is not possible at all. Okay. See, theta dash t. Once you have a theta t, you cannot you don't have any values of theta dash t. Okay, so here it is available, and with respect to nd solve 1, so from nd solve 1 they will try to get theta t and theta dash t with different points starting from 0 and 10, and then the one optional argument has been used is a aspect ratio as automatic. So they will define aspect ratio as per their requirement, and they will plot it. So plotting of the solution is this one. So this is your plot of the command. Not only this single equation can be solved, but also the multiple equation can also be used. The multiple equation means you can have the system of equation as well. So system of equation is nd solve. Let us say you have a multiple equation like omega t is theta dash t, omega dash t is equal to this one. So again, the similar kind of equation here. There are two variable wt and theta t. Okay, so for both of the equation, theta 0 and w0 initial value has been defined, then followed by the two dependent variable and followed by the independent variable with the corresponding range of the independent variable. So this is equation. This is a solution has been named as a nd solve 3. So whenever I will try to plot it, I will just call with the nd solve t. So again, in this equation has been solved in the form of, or it has been given in the form of interpolating function. Okay, so there are two interpolating function, one for omega and one for theta. Okay, again, if you want to plot this function, you have to plot by using parametric plot. So parametric plot, again, you have to evaluate this function because the function evaluation will take place to get the plot. So theta t, omega t, okay, with respect to what? nd solve t 3 1, and t is starting from 0 to t, aspect ratio is automatic. Okay, so again the same kind of, so both equation are actually same. You can see here both equation are actually same, only their representation is different. Okay, so this equation theta double dash t is equal to minus sine of theta t is same as this equation. Okay, same as, where is that, this equation. Okay, so you know that the second order equation can be converted into system of first order to first order equation. Okay, so the both equation are same, therefore the plot is also the same. Let me take another example. Lorentz equation. This is a three-dimensional equation. So x dash, there are three variable x, y, z. X dash t is equal to something y dash t. Now in this case, you can see that there are some parameter as well, alpha, beta, gamma. Okay, so alpha, beta, gamma. If you want to use it as a parameter, you can use it by using by some further function definition. So let me define another function which is called Lorentz plot. Okay, so what Lorentz plot will do, it will plot given Lorentz equation with some initial condition and some final values of the independent variable. Okay, with some values of the parameter. So Lorentz plot, this is another kind of function which has been defined just to iterate this function with different plots. You can use the same definition of the function by just assigning some parameter values, then initial condition, and then t max. Okay, so this function has this argument values ic and t max, and then it's what they are doing. It is a delayed plot here, delayed function input. So parametric plot 3D, because there are three equations, so there will be three equations, and therefore there will be three parametric functions. So parametric plot 3D. Then evaluate xt, yt, zt. Then this one, this will be with respect to the solution. Solution first, they will solve this Lorentz equation with values and initial condition in the range t starting from 0 to t max. Okay, now there is other optional argument. For example, for this parametric plot, there is other optional argument as a maximum points, how many maximum point you can take, and the more is the maximum point, more smooth will be your curve. So 10,000 maximum point I have taken, and t max is starting from 0 to t max. Again, plot points is 3000. Okay, and t max is a variable. So let us say that I want to get the plot of this Lorentz equation with a parameter alpha is equal to 10, beta is equal to 28, and gamma is equal to 8/3. So x naught is with initial condition x0 0, y0 1, z0 -1, and final point is t is equal to 50. So this is your, so let me first input the Lorentz equation, then define this function, and then plot this. So this is your plot, butterfly effect. So this is a Lorentz equation. Now, as I have said, there are so many optional argument in the ND solve 2, ND solve equation. You can say, you can put accuracy goal, that is what accuracy, up to what accuracy you want. Otherwise it is automatic, but you can override the default value as well. Compile is true, dependent variable is automatic, evaluative, all these things are actually the inbuilt optional one, which you can define it as per your convenience. Okay, so this finishes the final section, which is on differential equation. So now that is this meeting is left for any discussion or any problem you have, anything you want to discuss. That's it from my side.
Payal, are you there? Yes, yes, sir. Thank you so much. I think the volunteer is there. Yes, Payal, yes, you can start. Yeah.
Am I audible?
Yeah.
Yes, sir. First, we will be addressing some of the questions from the chat box.
Okay.
So one of the question was, how can we do matrix multiplication in Mathematica? It was by Mr. Dhrumit Trivedi.
Okay, so matrix multiplication is actually very easy. You have to use the dot one. There are dot product defined. I think I have not covered it, but if you go to help file, as I've said, anything, if you want any matrix operation. So dot product, dot is there. Is my screen visible? Is still visible?
Yes, sir.
Yeah. So matrix product, there is actually a dot operator used to get the product of the matrix, which is a simple matrix multiplication. But there is other one also, other thing also, that is element wise and other things there are some commands for that too. Okay. So for example, coordinator product is there, matrix power you can use, matrix expansion, and so on. There are so many things you can use it. Okay. Anything?
Okay, sir. Yes, sir. Another question is, how can we handle the data and optimize the data?
Okay. Okay, so actually Mathematica do handle data. That is, they can input some data from your text file or that file or whatever you have. Even Excel file, they can try to get the data from that, and you can easily manipulate it from that one as well. So for that, I think you can use the file data manipulation. I think that better. You can search it on the internet. There you will find so many example for that to handle those kind of data. There are so many things.
Another question by Mr. Umair Ujala. How can we simplify the solution of a differential equation containing complex function in the solution?
How can we simplify? I mean to say, I think, let me take one example. I think if I have, see, I have already, I think, done some algebraic manipulation from that. So if you have any expression, for example, once you get the solution, if you have any symbolic expression for in that solution, you can always use simplify command in conjugation, in addition to that one. For example, I don't have any equation like this, which is a complex one. Let me search my other one. Actually, the question is, beautiful thing is that Mathematica always try to give the solution in the most compact form. Okay.
Yes,
so once you have the solution, there is no need to simplify further, but still, if it is required, you can simply use those command. I think I have already told you that one in algebraic manipulation.
Payal, any other question from the
Yes.
audience?
Yes.
Yes,
For
ma'am.
example, simplify.
Another question is, while using desolve, sometimes we get a solution in the form of integral function as result. How can the integral function be removed, or if it can be removed?
In that case, if there is any integral function, or if somehow you are getting this equation input as the same, output as the same as input, that means for that equation it cannot be solved. Okay, it simply means that that equation cannot be solved. Okay, for example, let me try to get one example for this one. I don't know, it is very difficult to construct example here because Mathematica is so versatile that it actually gives you the solution. Let me get one equation, for example. Let me take this equation and try to modify it so that it doesn't have any solution at all. Do you know any function which doesn't have any solution? I think. Anybody remember? Tan x, tan of the square root of, let me try to get the square root of tan x. Tan of, I suppose that this doesn't have any solution. I think it's still running. I don't know whether it will have a solution or not. Okay, anyway, if I get this, if you get any kind of thing, whether it is a integral or any kind of, let us say this output is same as input. Let us say output is same as input. So that means if output is looking like this, the same as input, or the integral remains the integral form, okay, that means there is no integral at all, or there is no solution at all for that kind of equation. So it simply means that there is no possible way of finding the solution of that particular equation in closed form way. You have to only find the numerically then. Okay.
Yes.
That is the only thing.
Okay, sir. And sir, one question is from my side.
Yeah.
For the Lorentz equation, you mentioned this the Lorentz equation, you mentioned a parametric plot 3D.
What?
The parametric plot 3D command for, I think, plotting in the
Lorentz
Lorentz.
equation?
Yes, sir.
Lorentz equation. Yeah.
Yes, sir. So the graph, the butterfly graph we are getting, it's for the parameter or?
No, it is for XYZ.
Yes, sir. Okay.
It is your one coordinate is X.
Yes, sir. Okay.
One axis is X, another is Y, and the third one is Z. So XYZ. And the parameter values are used as alpha is equal to 10 because these are parameters. There are some parameter into it.
Yes, sir.
Alpha is 10, beta is 28, and gamma is 1/8/3. And initial value is 0, 1, 1. And
Okay, sir.
P max is 50. So this is actually a Mathematica function. You can say Mathematica predefined function.
Yes, sir.
You can use it to find the solution with given initial condition, given parametric values, and given final time. Yeah.
So there are more questions, but I think due to time restrictions, we'll just share your email ID and I think the rest they can email you their
I think,
queries.
sir, you can see the chat box flooded with questions.
Yes,
There
sir.
are various questions like Mathematica. Is it having optimization tools? Can we go for?
Yeah, of course. Every mathematical problem you can think of, every problem you can think of, Mathematica has some kind of answer to it. Okay, there is no if the mathematical community, if research has been done on that topic, if something has come out in that topic, Mathematica automatically evolve those functions into it, or it automatically captures all those things. Okay, whether it is a group theory or quantum mechanics or any other field, Mathematica always has a those kind of problem or those kind of solution you can think of. So every kind of solution, mathematical solution can be we can solve in Mathematica. The limit is unlimited.
Hello, sir. Myself, Dhumit Trivedi. Can we solve fractional differential equation in Mathematica?
Fractional, yes, you of course you can define fractional order one. Till now there is no inbuilt command, but you can as you are defining the fractional order derivative, you can define fractional order derivative, and you can of course customize it to give you the fractional order solution as well.
Okay. Thank you, sir.
Yeah.
Okay, sir. I think we will be sharing your email ID if you permit.
Yeah,
with
of course.
participants, so
Yes.
that whatever query they can directly email you.
Yeah.
One more request the participants are having for the presentation. So will you be able to provide the PPT which they are?
Yeah. I will provide it.
Okay. Thank you so much. While you can continue now.
Yes, ma'am. Thank you so much, Dr. Saroj Sahani, sir. It was a very precise and relevant session, giving a very unique position to all the participants that were present today to support or elevate us as learners, irrespective of our fields. The hands-on session, I think, gave things out to be more understanding and clarity on the use of Mathematica, which we can as researchers also take forward to apply to our present or future work. I'm sure all of us found the session to be extremely beneficial. Thank you so much, sir, for sharing.
Yeah, thank you all, and thank you, organizer, for giving me this opportunity to share my some knowledge about Mathematica. Although I have not covered every topic, and as I have said, it takes maybe months to take care of all those a single particular topic. It cannot be done in single session. So I have tried to cover every small things as far as I can, but still the problem is this session is open. Okay, you can call me, or you can even interact me later on whenever you feel easy to do that. So thank you all, organizer, and it was a nice to talk with all of.
Thank you
Thanks
so
a
much.
lot,
Thank
sir.
you, sir.
Thank you, sir.
Thank you.
Okay.
Yes,
regarding yeah.
yes, we will be now sharing the feedback form for the session. A gentle reminder that it is compulsory for all to fill all the feedback forms after each session for your certificate to generate. We shall now take a 30-minute break, and the next session or Scilab will start exactly at 2 p.m.
Saroj sir, if you are there, can you all please kindly switch on your camera so that we can just have a screenshot of each session?
Okay.
Yeah, thank you so much, sir. Mandeep sir, the participants, if you all can. Payal, can you please just take a gallery and then just, yeah.
Mandeep sir?
You continue, please.
Okay, sir.
Ma'am, I'm not able to access the gallery thing.
Okay, go to the view above. There are 3 options like.
Yes, ma'am.
Yeah, go to the gallery and then just wait for the participants to just switch on their cameras. I think they're still opening it, and then we can take a screenshot. Just for your information, the feedback form which we'll be sharing, it is also going to have an assessment of few questions. So you're supposed to do both of them and submit it. Okay, that are very basic questions related to the sessions. So kindly do that.
I will be taking the screenshot now. May I request all to smile? Okay, thank you.
Thank you. Bye.
Okay, thank you, Saroj sir. Yeah, Payal, kindly share the feedback form here in the chat box.
Yes, ma'am. I'll just share.
So we will meet at around 2 o'clock now for the next session.
Yes, ma'am. Next session will start exactly at 2, the Scilab session.
And a few people are asking about the YouTube link session that will also be shared with all of you through email. Every day in the evening, we'll be sharing the YouTube link also to all of you. So don't worry on that, as well as a presentation as participants are asking. Yeah, the form has been shared, so kindly fill that. We will post it in the WhatsApp group also.
Yes, ma'am, I'll just post it.
And just put the WhatsApp group link also there in the chat box if this participants have missed it anyhow. Ankita, kindly share the banner for the break session.
Yes, Ankita, you may start. Good afternoon, Lata ma'am.
Good afternoon, ma'am.
Good afternoon. Ankita, you may start.
Yes, ma'am. Am I audible?
Yeah,
Yes.
you are audible.
Good afternoon, everyone. I, Ankita Chandola, research scholar from Amity University, welcome you all to today's session on Scilab, a free and open source software used for signal processing, statistical analysis, fluid dynamic simulation, and modeling. It's a great pleasure for me to introduce our eminent speaker for the session, Dr. Lata Chanchlani ma'am. Dr. Lata Chanchlani ma'am, Assistant Professor, University of Rajasthan, is an eminent scholar and instructor with over 15 years of experience in impartment of education at various prominent academic institutions. Ma'am completed her PhD in mathematics with specialization in special functions, fractional calculus and Q analogs from University of Rajasthan, Jaipur. She has brought out textbooks and BSc courses on real analysis printed by a reputed publisher. Ma'am has presented research papers and delivered lectures as subject expert in international and national conferences and training programs. Ma'am has received several accolades for her committed contribution in social and educational field. On behalf of Amity University, Uttar Pradesh and all the participants, I welcome you, ma'am. May I now request Dr. Lata Chanchlani ma'am to please proceed with the session.
Thank you, Ankita, for such a nice introduction. Thank you so much. And I would like to thank the organizing team for making me the part of this 5-day workshop and organizing such a 5-day workshop in this pandemic situation. Thank you. Thank you so much. May I start, ma'am?
Yeah, ma'am. Yes, ma'am. You may start. Yeah, ma'am. You may share. You may share.
Is my presentation visible?
Yes,
yeah,
ma'am.
it's visible.
Okay. Well, today my topic is Introduction to Scilab. Scilab is a scientific software package for numerical computations, providing an open computing environment for engineering and scientific applications. It is developed since 1990, by researchers from INRIA, French National Institute of Research in Computer Science and Control, and ENPC. It is now maintained and developed by SciGAF Consortium since May 2003. It is an efficient in interactive calculations and automation of computation through programming. It provides all basic operations on matrices through built-in functions so that the issues of creating and testing codes, basic operations are avoided. Its power to constructing 2D and 3D graphs assist in understanding the data we work with. It can be used by students to understand the intermediate steps associated with the workout of many complicated problems. These all makes the software SciGAF an outstanding device for teachers and as well as students. It is distributed freely and open source through the internet since 1994. Since it is currently being used everywhere in educational and industrial environment, it is the outcome of the year of advancement and continues to be improved. Free as it is free of cost as well in freedom, because the source code is also available for those who wish to modify and improve it. It is equipped with hundreds of mathematical functions. It has been designed to be an open system where the user can define new data types, new operations, new functions, and whatever they want. SciGAF software's versions are available with us, 5.5.2, 6.0.2, and 6.1.0. The 6.1.0 is the latest version, which is available for both 32 and 64-bit, can be downloaded from the SciGAF homepage, http://www.scigaf.org. It works most on Unix system, including Linux and Windows XP 2000, 2010, and all. It comes with source code, online hack, user manuals, and after downloading it, we have to install it. After installation, a shortcut icon, you can see this type of icon is created on desktop screen. You can also see on my screen, this icon has been created. I can't show you still. This icon has been created on my screen also. This SciGAF binary comes with a basic set of functions, basic mathematical operations like addition, subtraction, multiplication, division, etc. Logical operations and or not, etc. These basic operations can be applied to various data types, Boolean, integers, floating points, strings, etc. Matrix manipulations, transpose, product, and sum of array elements, etc. Trigonometric functions, sine, cos, tangent, cot, etc. Elementary functions and user-defined functions, programming, conditional and loops, 2D and 3D plotting, line and bar graphs, surface plots, etc. Input-output functions. It comes with these are many binaries. Many of the features are, it comes with many features covering many areas of scientific computing, like differential equations, sparse matrix, linear algebra, statistics, graphics, interpolation, optimization, spreadsheet, and many more. To start SciGAF, we have to double-click the icon which have been created on our desktop, and after clicking this, we can we can see like this. You can see on my left side such type of screen. This is the SciGAF. This is known as the SciGAF environment. Is my screen is visible? My screen is visible.
Yes, it's visible, ma'am. You can continue.
Okay. The SciGAF environment consists of these docked windows. You can see on my screen. The first one is SciGAF 6.1.0 console in the mid part. And the left side, you can see file browser. And in the right side, three docked windows are. First one is variable browser, command history, and newsfeed. In the variable browser, we can see whatever the variable we define will appear here. And in the file browser, we can open any file from using this. And we, if we create any file in this, which will be appear in this side. And this is the command history. Whatever the command will be used will be appear here. And this is the news feed. In the news feed, we can find any type of news related to the software updates and many things. This is the SciGAF appearance environment, you can say. First of all, if you want to work in this Scilab, we can start our work in this console. The first way is to use Scilab interactively by typing commands in this console. In the console, after the prompt, you can see such figure. This is known as the prompt. You just type in a command and press the enter key. If we are working in the Windows or Linux, we have to press the enter key. If we are working in the Mac OS X, Mac operating system, we can find the output by just pressing the return key. Okay, as I am working in the Windows, so I use the enter key to find the output. So I can type here the command. Suppose I want to type S is equal to see the good. I'm defining a variable, see the S as a variable, see the good. We have to see, we should see good in everything. In this pandemic situation, we have to see the good in everything. So I have defined a variable S as a see the good. So then by pressing the enter, I can find the output S is equal to S see the good. You can type any of the command in this. Now I am using the function display function DISP display function, and I want to display this variable which I have defined S. So I'm using the display function DISP S. Then it will display our variable S which we have defined see the good. So it has appeared as see the good. In this way, we can work in this Scilab console and by pressing enter key and can find the output. Next, the tab key. If we don't remember any of the command, we just remember any of the keywords. Suppose I don't remember the complete command display and I will type this TI. Then after pressing the tab key, there will be after pressing the tab key, there will be a list of options will be available, and we can choose any of the command by using these. By pressing up and down arrow key, we can choose any of the command. And suppose I want to choose again display, then this display is coming here. See, so I'm clicking this and pressing, after pressing enter, I can choose this display function again. So the tab key is very useful. If we don't remember any complete command, then we can use the tab key. This again gives us the output see the good. So the tab key provides a very convenient completion feature. This makes a knitting appear in list appear in console and display a list box where items corresponding to or functions which begin with the letter. The letter, which letter? DI. With whatever with the functions will be with, started with DI will be appear in that list. The auto completion works with function, variable, files, and graphic handles and makes the development of script easier and faster. So this tab function is very useful to us if we don't remember any of the command. Next, some useful commands are also. This most useful command is to clear the. We should use this command always, because whenever we are working, we should type many commands. So to clear these commands, we have to type C and C for clearing the screen. See, I have typed C and C. It will clear my screen. Next one is the PWD command. Remember, PWD command. What will this gives us? This gives us the current working, in which directory we are working with. So it gives us the current working directory. It gives me C, users, HP, PC, document. So I am working in my computer as C, in the users and HP, PC, and in the folder document. So it gives me the current working directory of my work. Of course, when you type in this your computer, this on your computer, it should be different. Next, if you want to change the file name or working directory, or want to create some file in the working directory by using command diary. Suppose I want to write my file name, diary, inverted comma, my record dot, because it will create text file dot txt, and closing this. This is the command I'm using for creating. We can issue the diary command by typing this. This creates a file. this creates a file with name myrecord.txt in the current one. What is the current working directory? This is, you can see in the left side, this is the current working directory documents, and there is not any type of this file myrecord.txt in this. And after pressing this, this will create a file named myrecord.txt in this my current working directory. And after that, now onwards, the work will be saved in this file. Okay, see how? See, you can see now this is the myrecord.txt has been appeared in this current working directory. So now whatever we will do the work will be saved in this. If we don't want to continue or close the diary, we have to use the command diary and 0. This will close the work in that and save the, this will close and save the file myrecord.txt. Okay. So in this way, we can create a file or close the file and can find the current working directory. If anybody can't understand anything, can question next. It is convenient to work in console, but it is not recommended to work in console because the typing directly into the console has two disadvantages. What are the disadvantages? It is not possible to save the commands in this, because if I want to save this PWD, I can't save. And it is not easy to edit different kinds of, suppose I want to edit this PWD, but I can't move back. So in this console, it is not recommended to work in console. It is convenient. Yes, of course, it is convenient to work in console, but there are two disadvantages of working in this console. So I recommend that you to work in the editor. So we should work in the editor. The editor is appropriate to run compound. Is one advantage is also this is the editor is appropriate to run compound instructions. We can run many instructions at a time in this editor. So how can we open the editor? I will explain you. To open the editor from the console, click on the first icon. You can see there are many icons on my screen. This is for open the editor. This is for saving the document and whatever. This is clear. This is for clear the commands, and this is for help. Many of the commands are available on this toolbar. Many of the toolbars are available on the. We will open to open the editor. We will open this first icon. We can open this by using this or just typing the command editor. The editor will be open. See in the my right side. This is the editor. Okay, so in this way we can open the editor also. What are the advantages of working in editor? The editor allows, you can see editor, there are 3 files in my editor. First one is Amity Scilab, myscript.se, Amity SE. So you can see I can work many files at a time in this editor. So the editor allows you to manage several files at a time. I can manage 3 files at a time in this editor. I can work in on these 3 and run my command in this console. The editor opens with a default file name, untitled one. We can change its name by using the command save as. Typing in the editor is like any word processor. We can type in this editor using like the any notepad, wordpad. So we can edit, delete, type, whatever you want, you can do in this editor. Because we can move upward, downward in any direction like any word processor. So this is convenient to work in editor. Now, how can we console? How can we run the commands? How can we execute these things in our console? That we have to learn. Any file that can be saved by clicking file as, save as. In the editor, file can be saved by using file save as. The file generally have the extension .sce or .sci. You can see I'm using this file save as. Gives me the option amity.sce, but by changing the file type, we can use .sce, .sci, whatever we want. So by just clicking the just save, this will save my file. Okay. So these are the options available. So editor files in Scilab can be saved in .sce extension as well as .sci extension. How can we execute these files in editor in our console? There are many features which are worth to mention in this editor. You can see in my editor, there are many features, many functions available. In the top, you can see most important of them is execute, because we have to execute our work. When several commands are to be executed, because I have earlier explained, we are using editor because we can execute many of the commands at a time, several commands at a time by using the editor. But in if we are using that in console, we can execute one by one command. So it is recommended to work in editor. When several commands are to be executed, it may be more convenient to write these steps into files with Scilab editor. There are three ways to execute commands by using the editor. First one is load into Scilab. You allow to execute the statement in the current file. If we copy and paste, this will produce an output in the by just copy and paste the command. See, I'm using the file this. I want to copy a command. A is equal to today is Monday. Just I have copied and paste here in the console. S is equal to today is Monday. It will give the output as S is equal to today is Monday. Just copying and then pasting in the console. First method is this. How do we execute from editor to console? The second method is evaluate selection, allow to execute statements which are currently selected. We can select 2 or 3 lines in our editor. See, I have selected these 2 lines. S is equal to today is Monday and display S, and use execute this one. Execute file with echo. So it has executed. I have execute the selection with the selection. So it will execute the selection. So I have selected two lines. S is equal to today is Monday, and the second is display S. So both have worked. It gives us S is equal to today is Monday, and display S gives us today is Monday displayed. Okay. Next, third method is to executing is execute file into Scilab, allows to execute the file as if we use the exec function. If we can use the exec function, we can execute the complete file in our console. If I want to use exec, exec in the inverted comma, my file name is Amity. I'm working in the file amity.sce. So I want to execute the file amity.sce and close the inverted comma. And after pressing enter, it have executed S is equal to today is Monday and displayed S is equal to today is Monday. So both the command have been executed, and we can see in the console window. So there are 3 ways for executing any command using the editor. Just copy and paste the commands from the editor to the console window. Second, select 1 or 2 or 3, whatever whatever be the command you want to use. Then using this execute tab and use the selection. Okay, and the third one is using the exec function. So in this way we can execute our files from using the editor. So it is convenient to use the editor files and work in this. Now we can do many basic operations in this Scilab, like addition. I have earlier. I'm clearing the screen. Starting with the basic operations. Suppose we want to add 2 numbers, 2 plus 5, just 2 plus 5, and after pressing the enter, we can obtain the output as 7. Suppose we want to subtract 2 numbers, 8 minus 5, it gives the output as 3. So we can use it as a calculator also for basic operations. If you want to multiply 3 star, because there is no multiply sign on our keyboard, we are using star. 3 star 5, it gives us 15. 45 divided by 9, it gives us the answer as 5. So we can do all basic operations in this also, number operations. The Scilab editor follows the BODMAS rule. Okay, what is the BODMAS? First, it should open the bracket, then off, then division, then multiplication, then addition, then subtraction. Anyone can answer what will this expression give us the output as 32 plus 5 minus 6 star 10 oblique 1 plus 2 star 2. Anyone can answer? Can you hear me?
Please write the answers in the chat box.
Or you can give by unmuted. 25. Yes, exactly 25. It will give us 25. See in Scilab 32 plus 5 minus 6 star 10 oblique 1 plus 2 star 2, and after pressing the enter, we will get the output as 25. Correct. The correct answer is 25. So it also follows the BODMAS rule. The output is 25. Next, there are many predefined variables in this. In Scilab, the percent character is treated as a special character. It is used as a prefix to define mathematical constants as %pi for constant pi, %e for Einger's constant e. You can see %pi. What is the value of pi? You know that %pi, it gives us the constant pi, which is equivalent to around 3.14. So it gives us 3.1415927. So %pi for %pi for constant pi, %e for Einger's constant e, %inf for infinity, %iota for imaginary number iota, %i, and %t for true in Boolean algebra, factorial for factorial operations. See factorial. If you want to find the factorial 4, suppose it gives us the answer as 24. So these are the functions we can use. And suppose we don't remember the complete function factorial, we just type fact and then press the tab key. There will be appear many functions starting with fact. Suppose we want to use factorial or factor, we can use anything, whatever we want. So factorial, suppose we want to calculate now factorial 3, it gives us the answer as 6. So these are the functions predefined, and % character is used as a special character because it is used as a prefix to many defined mathematical constants. Of course, these are the case sensitive, because if you use SQRT capital in place of small sqrt. Small sqrt will give the square root of, okay, it gives us the answer as 3. But if we type capital SQRT in place of the small sqrt, if we use the uppercase letters, it doesn't give the answer and it gives us the undefined variable. So we have to remember this thing, that all the commands in Scilab are case sensitive. Okay. Next one is comments and continuation lines. We can put any comments in our Scilab commands so that we can remember the command. Suppose I want to add 2 numbers. First, I am clearing the screen by using the command CMC. Now, suppose we have given A 2 variables. A is equal to 4 and another B is equal to 5. Okay. Now we want to add these two, C as A plus B. Then for remembering this thing, we just comment by using these 2 slashes. We can give any comment by using these 2 slashes. This is, what is this? We can give any comment with whatever we want, addition of 2 numbers. The comment and after slash is considered as a comment and is ignored. It will not execute any type of this thing. It will only execute C is equal to A plus B and gives us the answer C, because A was 4 and B was 5, and it gives us C as a 9. And it addition of 2 numbers after these 2 slashes will not have been executed. Any type of error doesn't have come. So these are only for our command. So for putting any comments on in our work, we can use these 2 slashes. In Scilab, any command which ends with 2 dots. Suppose we are working in some mathematical calculation and some commands are very big, very large, so we can use this thing. if you want to put a command, so which is in 2 lines, so we can use these 2 dots. Suppose we want to calculate here %pi, which is nothing but pi, and e, %e is e plus iota. So it will give us pi. What is the value of pi? 3.14, and e. What is the value of e? Is 2.71, I think. So it gives us approx 8 point something and 3.14 something iota. So after by using this in these 2 lines, %pi star %e, and if we don't want to continue it in this line and we want to go in the next line, we will stop this by using suppose plus. We will leave this line by using these 2 dots and continue the same command in the next line by using these 2 lines, and then continue if you want to do %i. See, we haven't closed even the bracket in this line and continued into the next line. It will give us the output as 8.59743 whatever, and this plus pi iota, which is 3.14 iota. So we can continue any command in the next line by using these 2 dots at the end of the first line. Next step, we use semicolon at the end of any instruction for not showing the result. Suppose I have given some constant d is equal to 5, but I don't want to print it on the screen. I will use it later. Okay, so then I will press semicolon, then it will give us it accept the constant d as 5. See, in the variable browser, d is appeared as 5, but it haven't printed it. Okay, so not showing the results on the output screen and just recognizing, we can use the semicolon after any command. Okay, it have recorded d as 5, but not printed here. So for not printing any, if we don't put, suppose we want we give some e is equal to 9, and if we want to print and record it both, then it will recorded e as 5 and printed as well as e as 9 and printed as well as e is equal to 9. So by using this semicolon, if you don't want to show any output, then we put the semicolon after the command. The most important menu for the beginners is help menu. Many of the commands are also available through the menu at the top. You can see there are many of the menus are available. See, this is for opening the Scilab editor. This is for saving the command. This is for clearing the screen, and many more. But the most important menu for the beginners is the help menu, because we can't remember, we can't understand as early. So we can use the help menu. Okay, by clicking on the help menu, opens a help window. See, I'm clicking this help window has been appeared with a list of topics. There are many topics we can use. We can use help for any topic by using for graphics, for linear algebra, elementary functions, whatever we want, we can use any commands from this help menu. Clicking on the topics take into the documents to web pages. See, on the graphics, it gives us line space, method, any assignment, plenty of functions are available in this, and we can use it according to our work in this. Okay, for example, next one is help on. We can search also any command with whatever we want by using the search. Help on the specific command can be accessed from the command instead of having a navigate through a series. For example, help chdir. What will give us it? It gives us the syntax for change Scilab current working directory. So for changing the current working directory, we can use the command chdir, and the whole syntax has been given to us by using the help menu. So in this way, we can use the help menu also. Variables, assignment, and display. variables do not need to be declared in advance. It is not necessary to declare variables in advance, but we have to assign these according to our work as and when they are required. But any variable must have the value. Suppose I am typing here, I have given the values A, B, C, D, E, but I have not given some X. And if I will press X and then press enter, it gives me the undefined variable. So I have to give some value of X before using X. Okay. If we use, if a value is assigned to the variable A, there is no longer an error. If I assign X as pi by 2, suppose pi, because we are using percent pi by 4, then it will assign X as percent pi by 4, and it give me percent. What is the value of pi is 3.14/4, which gives me X as 0.7898. Now onwards, whenever we will use X, it will takes the value of X as 0.7853982. Okay. We can also it is not necessary to name the variables as A, B, C, D, X, Y, Z. Not necessary. We can give any name. Suppose I want to give the name pi by 2 and use it as percent pi oblique 2. It will appear our variable pi by 2. Okay, you can see this pi by 2 in my list. So pi by 2 is, you can see pi by 2 in my list. Oh, see this one, pi by 2 is as 1.57. So we can assign any type of variable, any type, we can name any type, any of these type pi by 2, not necessary X, Y, Z, whatever, Y, Z, W, not necessary. Okay. So pi by 2 is as 1.5779, and it has been recorded in our variable browser. Okay. Whenever we make computations and do not store the result, suppose we have calculated 3 star 4 minus 2. Okay. And we have not given the name, the expression, the name as to A, B, C, whatever. We have not given any name. So after pressing enter, what will we see that the variable answer has been come, and it gives the answer as 6. Whenever we use answer, it gives me the value 6 now onwards. But if we use again answer, then it will be give the latest value of answer. See, again it gives us the answer as 6. So the result is stored in default variable as answer. Okay. If we don't give the name, that it will be stored as answer. Okay. Now it is the quiz time. I want to ask some 1 or 2 questions so that I can check your progress. You can type your answers in chat box. Question 1 is, write the scilab command to find the current working directory in your computer. And the question 2 is, name the default variable in scilab as output. Yes, PWD is the correct answer. Good. Anyone can answer the second question? Second question. Yes, answer. Very nice. Very nice. You are learning well. Well done. Okay. Yes, answers are PWD for the first question. To find the command to find the current working directory is PWD, and the second is the default variable in scilab as output is ANS. Good. Next, we move to the next part of our presentation. Functions. First of all, I am clearing my screen. So CMC is the most used, functions. Functions are the easiest way to make computation. We use functions in, we use mathematics in physics, chemistry, in every branch of science, and there we use the functions. So it is most useful thing to how to define functions in our scilab. We can define the predefined function, as we have seen, exponential, factorial, square root, and many others. And we can define one. So user defined functions in this scilab. How can we define our own functions in this? See, functions are the easiest way to make computations for a variable from variables. Function definition in the scilab. Function definition begins with function and ends with and function. There are two commands, two things, function and end function. See, if I want to define a function, y is equal to 4x, suppose. So I'm using starting the command with function, then after using some space, because otherwise it will recognize y with the function. So after using space, function y is equal to fx and semicolon y, we are defining y as 4x. So y is equal to 4 star, and after using semicolon and function, it has been recognized that the function y as 4x. Now, if we want to calculate the value of y at x is equal to suppose 10, if we want to calculate f of 10, then it will give us f of 10. Then it will give us f10 is equal to 40. Of course, 44 into 10. So this is 40. Again, if we want to calculate f of 2, it gives us 4 into 2, which is 8. So we have defined our function y fx is equal to 4x. Next, suppose we want to convert degree Celsius in degree Fahrenheit. Okay, and we can define a function. We know that the degree Celsius in Fahrenheit is C. If we denote the Celsius in C, then 9 by 5 C plus 32. So we want to define this function as function and Fahrenheit. If I don't want to type this, I can use my editor in which I have already typed these commands, and I can just copy and paste these commands in my console. So it is convenient to work in this editor. You don't have to type big commands in again and again. I have just copied the command from my editor, Scilab, which I have already prepared, and then pasted it, and the function has been recognized. Now, if I want to convert degree Celsius, f of, here I have given the name, the function capital F. Remember, in the previous function, we have given the function as small f, and this function, we have given the function as capital F. So we have to calculate the capital F of 0. Suppose 0 degrees, we want to find 0 degrees Celsius into Fahrenheit. Then what will be the answer? As 32. Next, if we want to find the normal human body temperature in Fahrenheit, anyone can answer what will be the human body temperature in degree Celsius? Normal human body temperature in degree Celsius. 0? 32. Yes. No, 32. No. Degree Celsius, 37.2, around 37. Right. Good. So if you want to convert this degree Celsius of 37 into Fahrenheit, then f of 37 will be give us 98.6 in Fahrenheit. You know, 98.6 is the normal human body temperature, which is in the Fahrenheit, and it is in degree Celsius is 37. So in this way, we can define our own functions in this software, and also we can use another predefined function. See, we can define another function y is equal to gx as y is equal to 36 divided by 8 plus exponential of minus x. We are using the predefined function exponential for defining our new function gx. In this way, we can define some functions of functions also. Again, I am using my editor because I don't want to waste the time, and I am using my editor in which I have previously typed my work. Just copy and paste here. So this is the function we want to define. Y is equal to gx, where y is equal to 36 oblique 8 plus exponential of x. This function has been recorded. Now, if we want to find g of 12.5, it gives us the output as 4.99 as required, 4.49, whatever. So, but remember one thing, you have to give the different symbol. In the first example, we have given small f. In the second example, we have given capital F. In the third example, we have given small g. because if we will repeat the symbol small f again, then it will recognize the new one as a function and it will forget the previous one. Okay, so because we want to use both of them, so we have to use different symbols for these. Now we come to the next part of the presentation, next part of the lecture. Vectors, very useful term. It is used in physics, chemistry, and whatever. So they are here we define vectors as column vector also and row vector. So there are two different ways of printing vectors in this Scilab. For column vector, V is equal to square. We have to separate. If suppose you want to print a column vector 3, -2, and 5 in the square bracket 3, and we will separate for printing a column vector by semicolon 3, semicolon -2, and semicolon 5. And after closing the square bracket, we can obtain 3, -2, and 5 as a column vector. If we want to print a row vector, V is equal to, there are two ways of printing row vectors. V is equal to square bracket 3, just put the comma 3, comma -2, comma 5. It will gives us the row vector. And the another way is V is equal to 3, just put a space, not any comma, not any semicolon, just put a space, 3 space -2 space 5. It will again give us the row vector. So for defining row vector, there are two ways. Now we are doing some vector operations, addition, subtraction, etc. For this, I'm using vectors of complex numbers. So I'm taking the vector A is equal to a row vector in the square bracket 2 plus 3 star, because for using iota, I have to use percent character. So percent iota, and because we are doing the row vector, we can just put a space or put a comma. 2 plus 3 star 4 iota. Second entry is 4 plus 1 star percent I, and the third entry, because it is a 3 component vector 3. So not necessary this is a complex number. So I have put in 3 components, and it gives me 3 components as A is equal to 2 plus 3 iota, 4 plus iota, second one, and third one is 3 plus 0 iota. Yes, the decimal sign always appears, 3 dot, -2 dot, minus, yes. Next one is I am doing another vector B is equal to some another vector. We have to input another vector also, but that must be also of 3 component vector. So I'm giving the next component as next vector as 1 plus 6 star iota percent iota, comma 4 plus 6% iota, and third one is again 3. It gives the another vector B. No error. What is the error? Because I have not put in the star in between 6 and percentile. So I will put again B is equal to 1 plus 6 star percent iota, comma 4 plus 6 star percent iota, comma 3. Closing the square bracket, it gives the second vector. The first vector A is 2 plus 3 iota, 4 plus iota, and 3 plus 0 iota. And the second vector is 1 plus 6 iota, 4 plus 6 iota, and 3 plus 0 iota. Now, if you want to add these vectors, C as another vector, C is equal to A plus B. Suppose we want to comment. So I'm commenting this. This is the addition of 2 vectors. Addition of 2 vectors. It it is just it will just ignore this comment and it gives the output of C only as a plus B. Syntax oblique, I think I have used, okay, I'm doing again. C is equal to A plus B, addition of two vectors. It gives the output and it is recognized addition of two vectors after these two slash as only comment, and it gives us the output as C is equal to A plus B. C, you can see A 2 plus 1 is 3, 3 iota plus 6 iota is 9 iota, 4 plus 4 is 8 iota plus 6 iota is 7 iota, 3 plus 3 is 6, and 0 plus 0. So we can do addition of vectors. Similarly, subtraction of two vectors A minus B, and if we are not assigning any symbol for this, it gives us the answer only. Next one is we can generate vectors of more components in this. What happen if we write decimal number as row vector? Nothing will happen. We can write, see, I'm writing for you. Suppose as a row vector, I'm writing, suppose the vector A is equal to 2.5, and I'm using space for row vector, or we can use comma also, 3.6, and this is 1.5, and the third one is, nothing will happen. It will give the output. See, these three vectors are 2.5, 3.6, 1.5, nothing new, because this point is just a notation. This is not decimal, or you are confusing with this. You are confusing because this point is not for anything. This is just a notation. This nothing will happen, nothing new. Now we can generate a vector of 5 elements also, more than 5, many elements also, by using the command A is equal to line space 0. We are using this command for 0, 10, 5. We are using this command for generating a component, a vector with 5 components from 0 to 10. It is automatically will do equidistant. We have just given starting point 0 and the end point as 10, and number of points has been given. It will give us 5 vectors between 0 to 10. It is very important because we will use this type of command for generating data for our graphs also. So what will happen? It has given us a vector with 5 components, 0, 2.5, 5, 7.5, 10. So this is the another command for generating a vector with more than 2 or 3 or equidistant points. It is important, equidistant points. Suppose now we want to some another vector operations are, suppose we want to find the third components of this vector A. We have given a vector, and now we want to print only the third component of this vector. It gives the output as 5 because the third component is 1, 2, 3, which is 5. Suppose we want to find the sum of these components. B is equal to sum of A. Then it gives the sum of these one, 0, 2.5, 5 plus 7, because 5 plus 10, 15, and 2.5 plus 7.5 is 10, 10 plus 15 is 25. And we can find the mean also. Suppose we want to find C is equal to mean of A, then it gives the mean of the entries, which is again 5. And we can find the length of this vector because it is a 5 component vector. So D is equal to length of A gives me the 5 because it is a 5 component vector. If you want to find maximum of A, maximum entry, maximum component of A, then it gives us the maximum. What is the maximum in our A? It is 10. So it gives E as 10. So these are the some another vector operations we can do. Now we come to the next topic, matrices. Matrices, because in the matrices we have both rows and columns. So in order to print a matrix, we have to use semicolon and spacing. We will separate the rows by semicolon, and in a particular row we will use space for separating the entries. We can use also comma because we have learned in the vectors we can separate entries in a row vector by using simply a space or a comma. So if you want to type matrix A is equal to, in square bracket, 16 space 3 space 2 semicolon for separating the rows, and 5 again 5 space 10 space 11 semicolon 9 space 6 space 7. It gives us the output as a 3 cross 3 matrix. There are 3 rows: 16, 3, 2, 5, 10, 11, 9, 6, 7. Again, we will do some operations of matrices also. If you want to find a transpose of matrix A, with as another matrix, B is equal to A transpose. We just use B is equal to A dash. Okay, it gives us the transpose because as and the rows will be converted into column 6, 3, 2. The first row will be changes into first column. See what happened? 6, 3, 2 has been changed into first column 16, 3, 2, and the second row 5, 10, 11 is second column 5, 10, 11, and third row is 5, 6, 9, 6, 7 is as a third column 9, 6, 7. Another, if we are using another matrix M, some M is equal to, because I want to do some calculation, M is equal to 1 space 2 0 space 4. It gives us a matrix 2 cross 2 matrix 1 2 and 0 4. Now if we want to find this determinant of this matrix, just using the function det of, because I have given the name M, so det of M, it will give me the determinant of this matrix. What will be the determinant? 1 into 4 minus 0 into 2, which is 4. If you want to find the rank of this matrix, rank of M, what is the rank? You know, if we change the given matrix into echelon form, then the number of non-zero rows, here it is converted into echelon form, and the number of non-zero rows are 2 only. So it will give me the rank of this matrix M as 2. If you want to find the trace of a matrix, trace of M, what is trace of M? This is nothing but the sum of the diagonal entries of a matrix. 1 plus 4, which gives us 5. So trace of matrix is 5. So, and if you want to find the inverse of a matrix, suppose, so I am giving the name F. F is equal to inverse of M. Inverse of M. Then it will give us the inverse of matrix M as, because we can calculate adjoint of A upon determinant of A, it will give us into the fraction. So 1 minus 0.5, 0, 0.25 and all. So in this way, we can do also matrix operations in this. Some more matrix operations which we can do are, if you want to find element of matrix A, element of A in entry ij. Suppose we want to find, I have given the matrix A as it. If I want to find its entry A 2, 3, okay, second row and third column entry it will give us. So it is 11. You can see second row and third column, which is 11. So in this way, by using these operation, we can find more about the matrices. A I comma semicolon. Suppose I because this gives us the ith row. So if you want to find the second row, is colon 2 comma colon, it will give us the print the second row of the matrix A. Second row was 5, 10, 11. Okay. If you want to find the any column, so A colon comma J. If you want to find its third column has been printed 2, 11 and 7. See, 2, 11 and 7. In this way, by using these some another matrix operations, we can do many more with these matrices. If you want to find the size of matrix A, because it was a 3 cross 3 matrix, it gives us number of rows as 3 and number of columns as 3. If you want to find only the size of row number of a matrix, then A and size, okay, sorry, size A comma 1. It will give us the number of rows of the matrix, because here number of rows of matrix A were 3. So it gives us size A1 is equal to 3. If you want to find the number of column of a matrix, we will use size A2, and the length of A will give the total number of elements of the matrix. See, length of A. It gives us the total number of elements, which is nothing but 9, because it was a 3 cross 3 matrix. So the total number of elements was 9. In this way, we can do many operations of the matrices in this Scilab software. We can also define special kind of matrices by using, we don't have to type all the entries by using just these functions. We can also define some special kind of matrices. See, if we type 1, 2, 3, it will give us a 2 cross 3, 2 rows and 3 columns, 2 cross 3 matrix of 1, 1, 1 entries. See, by using the function zeros, suppose 3, 3, it will gives us a 3 cross 3 matrix with all the entries as zeros. Next command is EYE. It is important because we can use in many calculations. EYE. EYE, suppose we want to print an identity matrix with 2 rows and 2 columns. By using the function, we will use EYE. It gives us an identity matrix 1, 0, 0, 1 with 2 rows and 2 columns. Okay. So in this way, we can print, by using these functions, we can print some special matrices and use in our work. Now again, I want to check your progress. Anyone can answer. These are the 2 questions. Number 1 is, write the Scilab command to generate a vector A is equal to 2, 4, 6, 8, 10. And the second question is, write the Scilab command to print the matrix M is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. Yes, this one A is equal to 2, 4, 6, 8. Yes, name space. I want to, you can use also the function. First one is also correct, 2, 4, 6, 8, 10. And the EYE 3, 3 is correct, absolutely correct. And the min space 2, 10, 5 is again correct, because we want to type the vectors component from 2 to 10, and number of components are 5. It will gives us the vector 2, 4, 6, 8, 10. Good, very good, correct answers. Well done. Now we move to the next part of our presentation. Yes, these are the answers. Min space 2, 10, 5, and the second answer is EYE 3, 3. Now we come to the final part of our lecture, which is nothing but plotting. We can do many calculations in Scilab, as well as we can plot our graphs in this Scilab. We can plot many types of graphs, 2D, 3D, but I am covering here only 2D types of graph in my lecture. Producing plots and graphics is a very common task for analyzing data, creating reports, representing the solutions of differential equations numerically. Scilab offers many ways to create. There are many functions, plenty of functions are available to create many types of graph and customize various types of graphs and charts. Scilab can produce many types of 2D and 3D graphs. Graphics such as 2D and 3D can be generated and exported to various formats. Various format, you can see JPG, PNG, GIF, in which format you want, you can produce. Various formats, so that can be included in our document in the latex we are using into document for presentation. Scilab can export to PostScripts and GIF formats as well as to XFIG. Popular free software for drawing figures. We can annotate our figures in this. And the latex free scientific document preparation system. There will be a lecture of mine after the end of this workshop. And file formats. So we can create many types of graphs in this software and export it into any type of format and use in any type of documents we are using. So it is very important and very Scilab can create XY graphs, contours, 2D graphs, 3D graphs, histograms, bar charts, etc. Many types of graphs we can create in this. we can customize the graphs through a dialog box or using some command. I'll explain you later. We can set axis label, font size, color, etc. Grid, legend is the small description of the graph. For this, we have to select the figure properties from the edit menu. You can use this in the graphic window. In order to draw any graph, first we have to generate the data for the graph. So first we have to learn the data generation for the graph. There are two ways to generate a data for the graph. First one we have learned A is equal to namespace 0 to 0, 10, 5. It will generate a vector of 5 elements as you have learned, and from 0 to 10, whose first element is 0 and the last element is 10. So it will generate a vector 0, 2.5. See, A is equal to namespace 0, 10. We have used this function. I'm repeating this only for completeness of the graphics portion. Okay, what mistake I have done? A is equal to, I have not typed n in between I and s. A is equal to min space 0, 10, 5. It gives us 5 vectors from 0 to 10 and equidistant. This is the first way. The another way for printing or generating vectors of more elements is use this colon function. Okay, by using this we can also generate a vector. See, suppose we want to generate an equidistant vector A is equal to 1 to 10. If we have not specified the distance, then automatically it will generate equidistance vectors of 1 distance. 1, 2, 3. The distance between these two is 1, 1, 1, 1, 1, 2, 3 up to 10. If we specify some increment, then it will do accordingly. Suppose we want to generate A is equal to 1, 2, 11. We want to generate a data from 1 to 11, and at a distance specified increment is 2. So it will create a vector with the elements 1, 3, because distance between these is 2. 1, 3, 5, 1, 3, 5, 7 up to 11. Okay. The increment can be negative also. We can also decrease the data. Suppose we want to print a vector A is equal to from 100 to 0 with a decrease of 10. So we want to specify the increment as -10. So it will gives a vector with from 100 to 0 with 10 decrease, 100, 90, 80, 70, 60, 50, 40, 30, 20, 10, and 0. In this way, we can generate the data for our graphs. Then we will plot the graph for data generated. First, we will learn how to plot a XY graph. In order to draw, we need to set points to create a sequence of equally spaced points. We use the linspace command. First, I have created X as linspace. Again, I have not typed n. Linspace 1, 10, 5. I have generated a vector X from 0 to 1 to 10 and with 5 points. Okay, these are the points 1, 3.5 and so. And next point, because I want to plot the graph XY between X and Y, so we have to give also the data for Y variable. Y is equal to from 1 to 20 if linspace 1, 20, 5 equidistance point from 1 to 20. These are the points. Okay. Now, if we want to plot a graph between X and Y, just type the command plot X, Y. Okay. It creates a graph of X versus Y. It creates a graph See, this is the graph between X and Y. We can customize this graph. We can change the colors, anything by using figure properties. See, these are the figure properties you can see on my screen. By using this, suppose we want to change the color of x-axis, back color, font color. See, this is changing from red to blue, green. Back color is changing, black, green. Notice that green, 3 for green. We will use this. We have to learn also the name. Specification of these colors also. If we don't want to use this type of editing, aspects we can change, viewpoint we can also change. This is a 2D graph, but we can view this graph as a 3D. See, this is 3D viewpoint of this graph. In this way, by using the figure properties, we can change the appearance of our graphs. So, and in this way, we can draw. See, these are the commands which we haven't used, but because we were editing the graph, automatically appears. See, we haven't given these commands, but these command has been appeared due to we were using the changes in the graph. Okay, in this way, we can change the appearance of our graph, colors, axis, etc. I'm clearing this also. Next, we move to a 2D graph. How to plot a 2D graph? You can notice the graph window is labeled as 0. We haven't noticed. Again, we can draw another graph. Then we will notice. Okay, the next graph will be plotted on this window. Okay, we want to plot another graph. Okay, plot XY is time 3. But we have given XY, so not XY. We have used plot XY. What is a new thing here? We are specifying style as 3. Style is equal to 3 because I have, see what will happen. This is style as 3. This gives the style as 3. If not 2D, X comma Y, style is equal to 3. Again, you can see the graphic window number is 0. Okay, notice that the graphic window is labeled as 0. If we want to change the window number, we can use the command x at window 10. The next graph will be appear on the next window. I am for clearing the figure. First, I am clearing this figure. See, we use the command to clear the previous plot. We use the command CNF. It is important for clearing any figure. For clearing the commands, we will use CNC, and for clearing the figure, we can use CNF. Figure has been cleared. You can see. Now we can print any new graph in this. Next, we are doing not 3XY string 3 again, because string 3 was for green color, which haven't printed. Not X comma Y string 3. X comma Y. We have the graphic window or not? Yes, we are having not 2D X comma Y. First time clearing the CNF. First time clearing the figure. Okay, no graph is there. Now I am plotting 2D. Plot 2D X comma Y time is equal to 3. It gives me the green color. I have warned you, I have pointed out that see the 3 for green color. So because I have specified the string as 3, so it has been appeared in green color. This is the beauty. If you want to change the window, suppose we want to change this figure window, we use the command X at window. The new graphic window has been appeared with window number as 1. So in this way, we can change the window number also. Also, we can set the start point and end points for X and Y axis by passing, and the fourth argument is called the rect. we have given not 2D XY strength 3 and this rect 1, 1, 10, 20. What is the meaning? X is starting from 1 to 10 and Y axis from 1 to 20. See, plot 2D. First, I have to clear the previous figure, CNF. Again, plot 2D X comma Y comma style is equal to 3 comma rect equal to 1 comma 1 comma 10 comma 20. X axis from 1 to 10 and Y axis from 1 to 20. It gives the graph as in the graphic window. You can see this is the graph. X axis from 1 to 10 and Y axis from 1 to 20. In this way, we can specify the starting and ending points of axis. There are different strengths are available. I have given strength 3. Therefore, the graph has been in the green color. If we give the strength as 1, it will be in black. 2 for dark blue, 4 for light blue, 5 for red, 6 for pink, and 7 for yellow, 8 for white, 9 for blackish blue. Similar values for style can be given as negative also. See what will happen. First, I'm clearing the figures by using the command CNF. Then again, using the plot 2D X comma Y comma style as a negative number is equal to, suppose I'm giving the number as -2. What will happen? You can see there will be a plot with these symbols x, x, x for, because -2 stands for this one, plus, 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 whatever be the x, or for -1, the different symbol will appear. For -3, different symbol will appear. So for negative entries, for with a given negative, it will give the different types of symbol, and for positive, it will be different. For positive, it gives the different colors, and negative style, it will different symbols. There are many functions are available for plotting the graphs in Scilab. During the creation of graph, we use many functions in order to design the graph. Some of them are XGrid, used to add a grid, because we can annotate our graph, we can customize our graph by using many types of functions. So some of them are, first one is XGrid, used to add a grid on 2D and 3D plot. Title is used to display the title for graph. Legends used to display the legends for graph, legend descriptions about axis. X title used to configure both title and axis of the graph. Okay, and captions is used to draw graph captions. X label to label x axis, y label to label y axis, and z label is to label z axis for in the 3D graph. It is not for 2D graph. Now we can learn. Now we learn function plotting. How can we plot a given function also? Because still we have learned about only XY graph, and in which x and both have given to us. If we want to draw a function graph, we just have to give the data for x. It will automatically create by using the function for the y variable. So for function plotting, we will use, see, we draw a graph of some function. For this, we have to generate the data to be used for the graph. We have to generate the data only for one variable x, not for y, because we will define a function, we will give a known function, or we can use our own function. Both the possibilities are possible, both the options are possible. So here we have generated data only for x, not for y. We have given y as a function of x. So it will automatically generate the data for y-axis. Suppose we want to draw a graph of cos x from 0 to 2 pi. First, we generate the data for x-axis into 32 parts. We can generate any number of parts. I am using here 32 parts. So from 0 to 2 pi, if we want to break it into 32 parts, then we will specify the difference between two terms is pi by 16. So I'm using the function colon 0 to percent pi by 16, and again it will to 2 pi. It will generate data for x from 0 to 2 pi with a difference between two entries is pi by 16, and define a function for y as cos x. Then we will plot the graph with the command this. See, first I'm clearing the previous figure, and then I'm clearing the screen also using x is equal to 0, comma, not comma, colon, percent pi by 16. This is the difference between 2 points, colon, again percent pi 2 star percent pi. This will generate the data for x. Okay, data has been generated. Now you can give the function y is equal to cos x. Okay, y has been also data for y has been also generated. Now we want to plot a graph between x and y. Plot x comma y, comma, here I have given the point O as a symbol only, which will be appear on the points. Okay, I have wrongly typed the function PLOT, x comma y. This is the graph of cos x from 0 to 2 pi. 2 pi is around, 2 pi is 3.14. So 2 pi is around 7. So this is the function, this is the graph for cos x. Now we will further specify some annotations of the customize this graph also. How can we customize? By using the function. See, we have learned creation of many functions to design the graph. Now we want to design this graph by using the xgrid function. We will use xgrid function. See, xgrid 1. It will create a grid on our graph. See, this one, the grid has been appeared. So by using the xgrid function, we have prepared a grid in this graph. Next, if you want to tighten our graph, x tighten is being used for nomenclature of the graph. This is cosine plot. This is the name of the plot. This is on x-axis and this is on y-axis. See, x tighten is the function used to configure both tighten, that means the tighten of the graph, and axis of the graph, both the axis, x-axis and y-axis. I am using the function x tighten. Whatever be the name you can give. I have given, because it is a graph of the cosine function, so I have given the name cosine plot, comma, this is the name for x-axis, and the third one is the name for cos x for y-axis. This is the command for x tighten. This will create names for our graph and axis. Now in our graph, the name of the plot is cosine plot. On x-axis, the name is, label of x-axis is x, and label of y-axis is cos x. In this way, we can tighten our graph and axis also. We can export now, after creating the graphs, we can export the graphs to one of the supported formats. It may be GIF, JPG, PNG, PostScript, BMP, EMF, whatever you want, by clicking on file, export. See, file menu, in the file menu, by clicking export to, in which format, PNG, JPG, whatever you want, PDF, JPG, PNG, in which format you want to export, GIF, you can export the graph, okay? Or by just giving a command. What is the command for exporting the graph? XS2, see, XS2, JPG, GCF, I'm using GCF cosine JPG.1. Creates the best quality figure. For BMF, we will use, in place of access to JPG, we will use access to BMP. For GIF, we will use access to GIF. For JPG, we use access to JPG. and for PDF, for access to PDF, whatever you want, in which format we want to export the graph, we can export the figure. Okay, see, suppose I want to export the figure into JPG format. Cosine figure, we want to export the cosine JPG format, then we just have to type the command access to JPG, GCF, and so whatever this. So in this way, the R figure has been exported in JPG format. We can also draw two graphs at a time. See how? See, in the, you can see on my screen, X, we have given the data for X is in space 1, 10, and 50. But that is the data from 1 to 50 with 10 distance of 10, 10, and a function y1 as x square and function y2 of 2x square. We can plot both the two graphs xy1 and xy2 at a time in the same figure and tighten the graph and legends also. See how in the figure we have, no, first I have to clear the figure. CLF figure has been cleared. I'm using again the same command C. See, these are the two graphs. The first one is with the symbol OOO. This is for x square, and for these crosses is for 2x square. We can plot the two graphs with the same, and I have given also legend with this specify which the graph is representing OOO for x square and cross for 2x square. In this way we can explain each and everything in our graph. Annotations. Graphs can be annotated through commands line also. Grids, titles, axes, labels, legends, etc. can be added with the command. Next, we are moving to another graph with 2 or 3 functions. We have given x as 0 to 2 pi with a difference of pi by 16, and three functions, y as a 3 function, cos x. We can give same 3 functions at a time for y is equal to cos x space sin x space, and the third function is sin x cos x plus sin x. Now we want to plot x comma y, and the weaving tighten the graph as trigonometric functions. These are trigonometric functions, and on x-axis we want to label x, and on y-axis we want to label fx. X grid, we can create grids in our graph. Legends, we can specify what is the function and which one is the graph for cos x, which one is the graph for sin x, which one is the graph for cos x plus sin x. And %f for we will use %f does not draw a box around the legend, and if we use %t, it will draw a box around the legend. And one has been used for upper right corner. If you want to print the legend in upper right corner, we have used 1. If you want to print into top left, then we will use 2. If you want to print it on bottom left, we will use 3. If you want to use print it on bottom right, we will use 4. So these are the some symbol. I am drawing this graph also. First I can clear the graph. Previous figure, CLF. Previous figure has been cleared, and I am also clearing the screen. Now I want to draw this graph. See this one, x is equal to 0 to 2 pi with pi by 16 difference, cos y cos x sin x and cos x plus sin x, plot x y x title, and again with legends. Just copy and paste in our console. It created a graph with three figures, blue line for cos x, green line for sin x, and red for cos x plus sin x. Because we have given %f, so there is no box around the legend, and because we have given 1, so it is in the top right corner. If we will use 2, this will be on top left. Okay, in this way we can do anything with our graphs. So finally we come to the final position of our presentation. Finally one more round for you. Please answer these questions. Which function is used to configure both title and axis of the graph? Which function is used to export a graph in PNG format? Yes, first one is xtitle, good. And the second, PNG. Which function is used to export a graph in PNG format? No one can answer PNG, because we can export our graphs into any format. If you want to export into PNG format, which function? Yes, access to PNG, good. Nice work. The first answer is xtitle, title x-axis and y-axis. And the second is to export the graph in PNG format is, sorry, PNG, there will be PNG, not JPG, access to PNG. Okay, in this way, we can say that Scilab is an unpaid open source software for engineering and scientific computations. It is perfect for education and industries. It is better choice for MATLAB. We can, because it is free. MATLAB is not free. We can perform mathematical computation, algorithms, development, simulation, prototyping, and data analysis using this. So this is an important key for researchers at no cost. Thank you. So download, install, and enjoy it. Thanks. Any questions?
Ma'am, somebody wanted to know what is the difference between MATLAB and Scilab.
Both are same. We can work both of them, but the Scilab is open source software. It is easily available. We can download and install in freely from its official website. But in MATLAB, we have to some subscription or also anything.
Okay, ma'am. Any other doubts, please?
We can do many things as we can do in MATLAB in the Scilab as well.
Ma'am, I had a doubt. In special functions, for example, we have many generalized functions. If we consider one of the generalizations of beta functions, it includes integral or generalized Mittag-Leffler function inside it. So can we plot these kind of functions also in Scilab?
Yes, I have plotted in my work also.
I guess we don't have any other doubts.
Okay, thank you. Thank you so much, ma'am.
I would like to thank you, ma'am. Thank you, Dr. Lata Chanchlani, ma'am, for an enlightening session on Scilab. Thank you so much for your time. I'm sure all of us found the session extremely beneficial. I personally enjoyed a lot. Thank you, ma'am.
Okay, thank you so much. May I leave
now?
Sorry, ma'am. May I leave now?
Yes, ma'am, please.
Okay, thank you.
Thank you, ma'am. I would now like to invite our next speaker for the session, Dr. Pratibha Manohar, ma'am. Dr. Pratibha Manohar, ma'am, Assistant Professor of Mathematics in SKN Agricultural University, Jaipur, is a distinguished instructor with over 13 years of experience in the field of research and education. Ma'am has done her PhD from University of Rajasthan, Jaipur. She is a recipient of CSIR, JRF, and SRF. Ma'am has also received prize for the best paper presentations in international conferences. Ma'am has delivered more than 12 lectures and coordinated 8 trainings for teaching faculties. On behalf of Amity University, Uttar Pradesh, and all the participants, I would like to welcome you, ma'am. May I now please request Dr. Pratibha Manohar, ma'am, to please proceed with the session.
Thank you, Ankita.
Thank you, ma'am.
Ankita, please confirm if my screen is visible.
No, ma'am.
So, in the previous session, you have learned a lot about the basics of Scilab. Now we will be doing some advanced things. So I'll cover the conditional branching, iterations, and the defined functions in Scilab. So we will start with the conditional branching. What we mean by this conditional branching is that when we come across some problems where we have to decide that if this condition is satisfied, we will do something, and in the other condition, we will do other thing. In such cases, we do the conditional branching. We can understand by a very simple example that I've taken here. Suppose we want to take
ma'am, sorry to disturb you. Ma'am, your voice is not clear. Your voice is not clear, and your video is also not clear.
Is it visible now? So we were starting the conditional branching thing. We were taking a very simple example that suppose we want to take an input, a number from the user, and the program wants to check whether the number is positive, negative, or 0. So here we see we have conditions will check that number inputted by the user, we call it n, if that is 0, positive or negative. So to check that, we firstly enter here. I've made a simple flow chart to make it understand. We will enter here where we will check the condition if n is 0 or not. So at a time we will check two conditions, means either it is true or false. So we start with if it is 0 or not. So we check here that n is 0 or not, and we'll see if it is yes. We will display that the number is equal to 0. Means if the user has inputted 0, the program will display that the number is equal to 0, and here it will end. Next, if it is greater than 0, means if it is a non-zero number, then we need to check whether it is positive or negative. So we enter in the next conditional part where we check whether the number is greater than 0 or the number is positive. Again, we have two options, yes and no. If it is a yes, means it is a positive number, and we will display that the number is positive and the program will end here. And if it is a no, means the only option left is that n is less than 0. So here we do not need to check anything, and we will directly display that the number is negative. And again, it will end here. So in any case, whether the number is 0, negative or positive, in any case, we will reach here at the end. And meanwhile, we have displayed one message of these three, depending on what the number was. So now we will try to make a program in Scilab for this same work that I explained here. Can you see this Sci Notes window?
Yes, ma'am, it's visible.
Okay. So we will write a function that will check that when the user inputs a number, it will check whether the number is 0, positive or negative. So we will start writing a function. See, whenever we write a function, we start it with the name function and it ends with the end function. So as soon as I typed function, it automatically gives me end function. I do not require to write that. And now I will name this function as, what I'm checking is positive, negative or 0. So accordingly, I've named it. And from the user, I was taking input, the capital N. So this is function of n, means n will be input from the user, and accordingly I will display the messages. So firstly we were checking that if n is equal to 0. Here we were checking if n is equal to 0. Same thing we'll write here. If n equals 0. Here double equal means that we are comparing n with 0, and now the possibilities are this may be true or false. So if n is equal to 0, we were saying that we will display a message. Message will be the number is. If you have installed that Scilab on your systems, you can try it along with me. And if this is not true, means the else case, we call it if else case. So if n is 0, we will display number is 0. Otherwise, if n is non-zero, then we were doing that again a check that if n is greater than 0. So if n is non-zero, then if n is greater than 0, we wish to display that the number is positive. And if n is not equal to 0, then n is not greater than 0. The only possibility was that it is negative. So we will not check it. We already know that the only possibility left is that n is negative. So we will simply display that the number is, here I have two if. So for the first if, this and appeared automatically, and for this if, I should write and here. Now this program is complete. We can run it. And saving all these examples, I can share these examples with you at the end. And also, as I said, you can try them in between. So we have created a function pos next 0, and we have executed it. That means now the function is loaded, and now I can check whether the inputted number that was capital N here, if this is positive, negative, or 0. So here 3 is positive, and we had written here that display the number is positive if N is greater than 0. So it's working well. We can try other possibilities. It's negative, it's 0. So it was a very simple example to understand that how we can use the if-else case, the conditional branching. For a small problem, you can try for long problems after you have done a few examples. Let us take another example of conditional branching. Here what we do, we will take input from the user, a number, and we will check whether the number is even or odd. So we start here, take input from the user, and here we check the condition, means we divide the number by 2 and check the remainder. We know that if we divide a number by 2, then the remainder can be 0 or 1. If the remainder is 0, that means the number is even. If your remainder is 1, that means the number is odd. So if remainder is 0, means when the number is divided by 2 and the remainder is 0, that means if it is a yes, if remainder is 0, we will display that the number is even. If it is a no, means when we divide the number by 2, we get 1, means the number is odd, and we will display here that the number is odd. And in both the cases, the program will end. So it will simply check whether the inputted number is even or odd. So let us write a program here. If you face any difficulty, you can intervene in between. So now we are writing the second example where we are writing a function which will check even or odd. And we will take input. We were writing number there, so we can write number. We have written function the same way we were doing the previous example. Now, when the user has inputted number, we will firstly calculate the remainder after dividing it by 2. So I call it REM, the remainder. And we will use an inbuilt function. Modulo is an inbuilt function in Scilab, which finds the remainder. Means when you divide the number by 2, then the remainder that will be saved in this REM. So once we find the remainder, we need to check. What we check, that this remainder is 0. If this is 0, means the number is even. We will display that the number is even. And the other possibility is that the remainder will be 1. So there is only one possibility, so we do not require extra if here. So we simply write else. If remainder is not 0, we will display that the number is odd. This is it. Here we had if, and here we have ended it. It's looking good. We can try to run. So we will check even odd. The number name I'm writing here is the name of the function that I gave here, even odd. And number, suppose I take 10 and the program is working well. It divided 10 by 2 and the remainder was 0. So it displayed that the number is even. This number is odd. I hope these two examples are clear. And as of now, we have worked on only displaying some messages. Other than that, sometimes we have functions defined in terms of sections. Then also we calculate those functions. That can also be done using this if-else. For that, suppose I want to define a function. I call it fun, and suppose it depends over x. If I suppose it is defined in 2 parts, if my x is greater than 0, then the function value will be x plus 5. Otherwise, means for positive x, this is x plus 5, and for negative, this is x minus suppose 10. So in this case, we are calculating some function, and we have defined it in such a way that for x greater than 0, it gives some value, and for other part of x, it gives some other value. So as of now, it will calculate f, but we want to display our output. But here, in spite of using that display, we use printf command, because display is used when you are displaying some statement. So here we want to print that the value of f is, and we want to display whatever the value of f is calculated over here. So to do that, we'll here write %f and here f. Please don't confuse this f with that f. We can in fact change this. We can write g, but still here we will use f. It shows that whatever is the output, whatever is the value of g, that is stored in the system as a floating point number. So that g, that value, will then be written here when it will be displayed on the output screen. So let us run this. Function was named fun, and to x, suppose I'll give a positive value and a negative value. If I say x is 3, so it will be calculated here, and we will get, since we are taking a positive x, it should be calculated from this statement g equals x plus 5, and it should be 5 plus 3, that is 8. Let us calculate here. It's 8. Again, I'll take a minus value. I take minus 2, it is minus 2 minus 10, that is minus 12. You can see there are 8.000 minus 12.00, which is appearing over here, because I have chosen that the output should be stored in the system as a floating point number. Instead of that, I can use d, then in that case, it will be stored in terms of integers. And in that case, it will simply display 8 minus 12. But since we can give this x some value like 1.5, so in that case, it is better if we keep this as f, a floating point number. I hope if case is clear. As I said, if you have doubts, you may ask in between. Let us move to the next part. The user-defined functions, though you are already aware, but I'll still be using some function with more variables. So let us check out some problems. When we define a function, we can have more than one input variables and more than one output variables. Again, we will write them in function and end function, and in between of those, we will define the function. Means this part will include the definition of the function. Let us do simple examples for that. Suppose I want to define a function which has one output variable. You can see the syntax. I'll write the same here. Syntax had square brackets and then the output variable, and here the name of the function, then small braces and the input variable. So I give it a name, my function, and in the input variables, suppose I keep these x1 and x2. Now we calculate here this z. Suppose I calculate it, this is x1 plus 2 into x2. Now if I run it, it is my function. Now I have two input variables, x1 and x2. So I give some values to this x1 and x2 here. we see that the answer is 8, means x1 was 2 and x2 was 3. It performed the calculation x1 plus 2x2 and it printed the value of z. Please note that I have not used any printf or any display over here, and it has directly displayed the value. Though if I do not declare my output variable and still I run it, I'll not get any value. Since I have not declared the output variable, it will not display me the value. But I can do one thing, that I can use printf. I want to display the value of z. Again, we take it as a floating point data type. The value which is stored in this z should be displayed here. Now, if I run it, it's my function in this console, my function. Now it is displaying the value of z where I have not declared the output variable. So one way of getting the answer is that I declare here the output variable, and another one is that I write here simply printf. Now, as of now, we have taken only one output variable. In case we have two output variables, for example, z1 and z2 are my two output variables. Z1 is defined like this, but Z2 is defined as x1 minus 2 into x2. And since I've declared the output variables, as of now, I would avoid this statement. You might know that as soon as I put these two backslashes, now this line will be ignored while executing the program. Now what happens? Still I'm getting answer 8. I had two output variables over here, so I should have got two answers, the value of z1 and z2. But we are getting only one value. That was the value of z1, but it is not displaying the value of z2. So this is the matter, that you cannot always use it like only writing these output variables in the square brackets will not always work. And the best way is that we use this printf and we say the value of z1 is this and the value of z2 is. See, firstly, I've written this first %f is for the value that is calculated in the z1 output variable, and the next %f is for z2. So by default, first %f will be taken from this z1 and the second %f will be taken up from this z2. You can display any number of variables from here. Now let us try to compile. It has calculated z1 as well as z2 and displayed the values. Z1 was 8 that we were also getting when we were declaring the output variables and not using the printf. But here we have also calculated and displayed this z2 variable. So in this way, we can define functions with many input variables as well as many output variables. This one example I would like you to try. If you have installed this Scilab, you can try these two. Just try to put this z1 and z2 in terms of a function. I think 5 minutes will be enough if you are trying. Okay, some of you have done it. Best if you have not installed Scilab, you can install it later on and you can try these examples. So I'll share the examples that I am explaining here right now. Now we are using this data types in some examples. Still, I would like to tell you here that what are the usually used data types. We use this %c when we want to display a character, and S for string, D for integer decimal number with sign. This we have used in the previous examples. I is for the same, then U. When we display integer decimal number without sign, we have F for real numbers with sign. F the floating point number I told you, mostly it takes long memory in your system, but still you can use it If you don't want to remember all them, you can mostly use %f in case of numbers. Then G will display a real number with sign in a short format. Usually F prints something like here we have seen -4.000000. So G will take a short format. E with sign in exponential format. But mostly your work can be done with the C, S, and D, F. So after the if-else case and the user-defined functions, we are moving towards the iterations. Iterations solves many of your problems, like someone from you was asking that when we have Mittag-Leffler function. So Mittag-Leffler function is usually a series. So when you have a series and you want to sum it up, that time iterations will play its role. Any series can be summed up using iterations part. So again, we'll start with simple examples, but you can take it to as difficult level as required in your research work. So firstly, we'll just take an example. Obviously, we will sum up, as I was saying, it is used in series, but in this simple example, we will add up the natural numbers. Suppose we are writing in program for adding first 50 natural numbers. So how it works, we start it. We are already saying that we are adding first 50 natural numbers. So we do not require any input from the user, or we may let the user define, user give the number. If the user says 25, then we will add the first 25 numbers. But as of now, I have created this flow chart for n equals 50, means we are adding the first 50 natural numbers. Firstly, we will initiate our sum with sum equals 0 and n with n equals 0. This part is called the initiation part. We have started the iteration with the sum 0 and n 0. We move further, we enter a loop. This part is a loop because it has arrows going down and then arrow coming up again and then going down. So this is a loop. When this n enters the loop, n is incremented by 1 and sum is given the value sum plus n. These two we can check here in the table. Initially, before entering the loop, the value of n was 0 and the value of sum was 0. Then we entered the loop and we incremented n by 1. We say n is equal to n plus 1. So the value of n was 0 and now the value of n is 0 plus 1, that is 1. And the value of sum is sum plus n. Sum is 0, n is 1. So the value of sum is 0 plus 1, which is equal to 1. Now we enter here where we have conditions to be checked. And here we check if n is equal to 50. If this is true or not. As I was saying, I am adding first 50 natural numbers. So here I have added only 1. The value of sum was initially 0. I added 1 to it. Now I want to add 2, 3, 4, 5 up to 50. So I will continue to repeat the loop as long as n is not equal to 50. So if n is 50, I'll exit the loop. If n is not equal to 50, if it is false, I'll go back here and I'll increment n by 1. So the value of n was 1. And now after increment, it will be 2. And the value of sum will be sum plus n. The previous value of sum was 1. And the value of n was 2. So every time I perform this iteration, the value of sum and n will change. And now the new value of n is 2 and the new value of sum is 3. Again, we will go here and we will check if n is 50. No, we will go up, we will increment n, we will increment sum, and in this way, we will keep incrementing n up to 50.
When we will enter here and the value of n is 49, we check n equals 49 plus 1, which is 50. We again do the sum. We reach here. We see is n 50. It's true. It's true means we have added all the numbers up to 50 and we will come out of the loop and value of the sum will be displayed. So firstly, we need to check that when we are saying that we are going back in the loop as long as this n is not equal to 50. So I would like to ask you that how many times did this loop run? I am trying to find the sum up to n equals 50. I will exit when n equals 50. So I've added n equals 50 also in the sum. So how many times did this loop run? You may give your answers in the chat box. My question is that we initiated n with 0. We entered here and the value of n was 1. We moved here. We checked if n is 50. That's false. We moved back here. We said n is 1 plus 1, 2. Then we moved up to the end. So firstly, when we entered here, n was, we entered back, then n was 2. And we did this 50 times when n was 50. Or we did it 49 times. Only a few answers have come yet. Okay, I will let you think over it when we will be writing a program for this part. It's quite easy to understand the flow charts, but still you need some skills to write the program. So now we are interested in writing a function which does the summing work. And we want to as I said, I was adding up to 50 natural numbers, but now I will allow the user to input n and I will add 1, 2, 3 and so on up to n. So I'll initiate my sum with 0 for I equals 1 to n. We will perform 1 plus 2 plus 3. So we'll say that sum is sum plus I. But if you confuse the symbols, I can write it m and then it will be n. So I'll take input m and my n will run from 1 to m and sum will be added to n. This is what we were writing here. Sum will be sum plus n and n will be n plus 1. I initiated n with a 0. Here also I can initiate it with 0, though it doesn't matter. Okay. And the increment that was given to n, that we were saying n is equal to n plus 1, that we do not require to write in the program, because n equals 0 to m by default means that it will firstly take the value n equals 0, then it will take value 1, then 2, then 3 up to m. And when the sum is performed, we wish to display the sum of first. This m will be inputted by the user, so we can say it's %d. Obviously, we'll take integer. Sum of first m natural numbers is, and this is sum, but here we'll write %d. And first %d is the number that user has inputted, that is m, and the second %d is the sum that has been calculated. Let's run it. Now we were calling it summing, and we suppose take a small number so that we can also add it and check. So sum of first 3 numbers, 1, 2 and 3, that is 6. With the same speed we can perform big calculations. Was 30 natural numbers, that is 465. So it's simple. So again, how many times did this loop run? Earlier my question was that we had actual 50, but here we are having m. So how many times did this for loop run? So firstly, I took n equals 0, then 1, then 2, then 3. So this one is running m plus 1 times. When I said I take n equals 1, 2, 3, 4 up to m, these are already m, and other than them, I had taken n equals 0. So m and 1 extra n equals 0. So these are m plus 1. Though we already have a mathematical formula to calculate the sum of n natural numbers. So you can calculate it easily from there also. But this is interesting that here we can take the increment as it suits to us. Means now if I say that I am adding these numbers while incrementing this n by 0.5. Please note that when we do not write anything here, this n will be incremented by 1. But if I am mentioning 0.5 here, that means it will take a value of n as 0, then 0.5, then 1, then 1.5, then 2. And we can try run the function. So it has added 0, 0.51, 1.52, 2.53, 3.54. And you can take any other spaces as required by you. So we have used for loop for doing sum. And this is easy to understand that whatever the series is, we will usually initiate it by sum equals 0. I'm mentioning that because now I am moving towards a product series, means when we are to multiply in a loop. If it is so and we initiate it by 0, then 0 multiplied with anything will give you a 0. So when the series is a product series, that time we will initiate our prod by 1. When it is a case of sum, we will initiate by sum equals 0. But when it is a product, we will initiate by prod equals 1. So it's a very, again, simple example where I'm trying to find product of 1, 2, 3 up to 8. So initially we have taken n equals 8 that we can leave to the user what he wants to define. And I've initiated I and prod with 1. We will enter the loop and we will say prod is prod into I and increment I by 1, and we will keep going back to the loop as long as this I is less than or equal to n. If I is less than n, which was 8 here, we will go back and do the multiplication part again. We can always dry run the program before trying to run the program that we have written. So when we dry run this flow chart, we get for n equals 8, the value of I and prod was 1 initially. Then the product was performed. Product was product cross I. So 1 cross 1 is 1. See here, I'm able to do 1 cross 1, then 1 cross 2, then 2 cross 3, then the result was 6, and then 6 cross 4, result is 24, then 24 cross 5, and so on. How I did that? I just kept incrementing my I with 1 and multiply this new value of I with the new value of prod. New value of I is multiplied to the new value of prod, the same way that we were doing the sum part. Now, let us write a program for this. So we want to define a function which performs product of first and natural numbers, and we initiate our prod with 1, and then for I equals 1 to n, we were doing product equals product cross I. Same thing that we were writing in the flow chart. Prod is prod cross I, and I equals to I plus 1. We do not require to do that. That increment of I is done automatically. And when we exit the loop, the final value of product is the product of first and natural numbers. And we simply display it. I've used 2% D. First person D is taken from this n, the input by the user.
So the product of first, like I was taking 8 in the flow chart, first 8 natural numbers is, so I want to find product of 3 natural numbers, that will be 6 for 30. It's a big number. Let's 15. Now the same way we changed the space in the sum part, we can also do that in the product part. And one more thing is that we can perform the sum and product together in the same program. If I initiate sum with 0, since I am using I1 to n, if I say sum equals sum plus I, and while printing, I can add here in this line that product of, or I can write a separate line that print the sum of first, and now first one is the n and second one is the sum. First 3 natural numbers, the product of first 3 natural numbers is 6. The sum of first 3 natural numbers is 6. We do not like the display. It should appear in the next line, then it will look better. Let's try 4. Product is 24 and sum is 10. So we can do multiple things in the same program. We'll try to write program for actual functions that we face. We usually do not require to sum or product the natural numbers, but we actually need to sum up the series. So I have taken a very simple example. Exponential is well used in all the fields. This is series representation of exponential where n is from 0 to infinity. This n factorial, 2 factorial, 3 factorial, we have an inbuilt formula, inbuilt function. Like we had a modulo for this factorial, we have an inbuilt function in Scilab. So we will try to add this series using Scilab. So that's a new program where we want to calculate exponential of x. We had infinite number of terms over there, so we would like to select n, means we will choose a number n, that how many terms we would like to be added. We cannot write infinity here, so we will select the n, that if we want to add the first 10 terms or 20 terms, obviously as many terms we can use in it, we'll get a better result. Now we will take this x from user, and the number of terms will also be inputted by the user, and we are going to perform sum. So we should initiate our sum. Suppose we initiate it with 0, though the series started with 1, so we can take sum equals to 1 also. I think that would be even better. The series was 1 plus x square by 2 factorial plus x cube by 3 factorial. So I say sum is equal to 1. So I need to add rest of the terms. And then for I equals 1 to n. Firstly, I should calculate the nth term of the series. That was x power I. As I said, we have inbuilt function factorial. So it was x power n upon n factorial when the sum was running over n. Instead of that, I've used I. If it confuses you, we can change it. Suppose, so n is running from 0 to infinity, but here we will choose a finite number. So n is running from 1 to m. M may be 10, 20, whatever the user inputs. And after calculating this nth term, we will add it in sum. So firstly, sum is sum plus xn. The value of sum was 1, and xn
for n equals to 1 was x power 1 by 1 factorial, then it will be x power 2 by 2 factorial, and every time it will be added to this sum. Now we would like to display exponential x was, so first %f is the value of x that user inputted, and second %f is what we have calculated by summing up. So let us run it. Suppose I take 4 terms. Exponential. Typing error. Exponential of 3, 4. It did not run. And now, so exponential of 3 is 16.375 when I've added 4 terms. That's actually 5 because 1 we added directly to it. And if I take 10 terms, the value is increasing because I'm adding more number of terms, and I should actually select a value which are approximately same, like here 16, 20 means it can increase more. So 310, then I could try to 325. I better copy it. Now we see it was 20.07 for 10 terms and 20.08 for 24 terms. Means now the nth term, the value of the nth term is not too big, and we can say that this is the approximate value of exponential 3. Last thing I would like to tell you that this was not the best way to sum a series, because here in spite of giving it some error tolerance value, we were manually checking that if the value of this function is almost the same, that we can say that this is the approximate value of exponential 3. But we have better methods of doing that, and we do that by a do-while loop. So the last one, while and do while. Better keep a shorter name. Exponential of x. Here I am not giving n because I am not letting the user enter the number of terms that is to be added, but I will prefer to give an error tolerance that I will keep adding the terms as long as the value of the nth term is not equal to some given very small number. So for that, before I give the initial values, I'll say that I'll use while. While the absolute value of nth term is greater than point, suppose, means as long as the value of the nth term is big enough, we will keep adding that. And if I find that that is a small one, we'll start skipping the term and the term after that. So firstly, we need to calculate this xn. Xn was the nth term, which was x power n upon factorial, and then we were performing the sum. Now here we have taken some things like I'm saying when the absolute value of xn is greater than 0.001. This is a loop, it will continue, but firstly I'll have to enter into the loop. For entering in it, I'll have to give xn some value. I'll have to initiate it with a value which is greater than 0.0001 so that it once enters the loop. Once it enters the loop, it will automatically assign some value to this xn, and thereafter it will continue to be in the loop as long this xn, the absolute value of xn, is greater than 0.001. And one more, I've given sum here. So sum, like we were doing, we will take sum equals 1. And also we are saying that we are using this x power n, but for the for loop, we were saying n is equal to 1 to m. Here we were giving n is equal to 1 to m, but not in this example. So what do we do? Like we were writing in the flow chart, we will keep incrementing n by 1. And also we will have to initiate this n. So the first term was 1. 1 is automatically being added because I've given sum the value 1. So then for the next term, we have x power 1 by 1 factorial, means n should be initiated with a 1. It will come here. It will say x upon 1 factorial. It will be added to the sum, and then the value of n will be 2, and it will go back up here. It will check if the absolute value of xn is greater than 0.0001, and it will continue doing this. When the absolute value of nth term is small enough, it will exit the loop, and we will display exponential of, it can be %f also, equals the value that we have calculated, that is stored in the sum variable. Let's see if it's working well. It's 4. We had already calculated the value of this exponential for 3. So let's check for 3. I had 2% f here, and I have not mentioned this x. Now let us execute. It's x43. So you can see we are getting the value 20.085523. When we were executing this one, where we were inputting this m, that time we had used good number of terms and we were getting the same value. Still, we cannot say this is the exact one, but here we have, without counting that how many terms we have added, we have actually worked on the error tolerance and we have added the series. If there is anything you want to discuss on it, you can do that. I've explained whatever I wanted to. You may leave your questions in the chat box if you want to discuss anything, if you have any function or any problem that you feel to be similar. Like, as I said, someone from you was asking about the Mittag-Leffler function. Mittag-Leffler is quite similar to the exponential function. So that part can be done using this while or the for loop.
Any participants has any other questions? I think we have no questions, ma'am.
Oh, I have saved all these examples and I'll share them with you.
Yes, ma'am.
The examples we have done here that I'll share.
Yes, ma'am. Thank you. So thank you, Dr. Pratibha Manohar, ma'am, for this wonderful hands-on session. We are very grateful to have you here. We all enjoyed and learned a lot during the session. Thank you so much, ma'am.
Thank you. And thank you, Rupakshi ma'am, for giving me an opportunity to talk with so many people on this good topic. Thank you, ma'am.
You are muted. Rupakshi ma'am, you are muted.
Sorry. Yes, there is a one question, a very small question, that what is the benefit of learn Scilab? I think I can see in the chat box. What is the benefit of learn Scilab?
Actually, if you can see, if you are calculating exponential by hands or by calculator, you can do the exponential, but not the Mittag-Leffler function. So there are so many product or summing series that you come across, and we cannot keep adding them manually, or even using Excel is more tiring as compared to the Scilab. Just write a simple small program and it will work for your series. Even it works good for the product series, and since it is free, so anyone can download and perform all these calculations so easily.
One question was related to fractional differential equation. I think, Ankita, you have put on the question also, right? Am I right?
Yes, ma'am. Yes, ma'am. Ma'am, somebody is asking, can we compare it with MATLAB?
Yeah, you may actually, it is quite same as MATLAB. MATLAB may give some more options. Obviously, that is a very well paid software, so that has more options. But still, I think regular things can easily be done in Scilab, and you may sometimes see even not even in Scilab, you can do everything in C programming also, but that will take more effort from you, and Scilab will concise it. So similarly, there may be many things that MATLAB can perform even easily, but still you can use Scilab. Being free is a good advantage on it. if you can solve fractional order differential equation over MATLAB, then you can solve over Scilab also. See, all the fractional order differential equations cannot be solved on these softwares. And usually MATLAB also, it's not very good when you are working on solutions of differential equations. I think Mathematica works better because it gives your answers in terms of functions, while MATLAB and Scilab, they will usually give you the values in terms of numbers, not functions.
I think the same question was asked in the previous session. I think you don't have any inbuilt function for fractional, if I'm not wrong. You have to customize it and then you're supposed to.
Yes, of course.
Okay, Ankita, you can proceed. Yeah.
Thank you so much, ma'am. Thank you for joining us.
Okay, thank you.
Pratibha ma'am, if you don't mind, can we open our videos, all the participants, we can have a quick screenshot of this particular session, if it's fine with you.
Actually, I cannot hear you.
Can we open the camera and take a screenshot? If all the participants can switch on their video, and if you can also do this if it's possible. Yeah, thank you so much, ma'am. Ankita, can you take it a view gallery and please take a screenshot?
Yes, ma'am. I only have 4 people on video mode right now.
Okay, you just, they are switching it on.
Yes, ma'am.
Go for gallery view. It's above view.
I've done that, ma'am.
Just wait for 2-3 minutes. Let them switch it on and then we can take a screenshot. I think so Jitendra sir also here, I suppose. Yeah, kindly take it, Ankita.
Ma'am, Rupakshi ma'am is joined. Can we just wait for her?
No, she has some network issue right now.
I am taking the screenshot. Rupakshi ma'am is here, ma'am.
Yeah, she's there.
I am taking 1, 2, 3, smile. Done, ma'am.
Okay, thank you so much. I suppose this is the end of day 1. And I think the feedback form has already been shared.
Feedback forms has been shared, ma'am. And also the briefs for the next session has been shared.
Okay, so let us meet tomorrow. So tomorrow we will be meeting at 10 o'clock and we'll be having the first session of MAPL. That is for 2 hours. And then we will be continuing for SPSS. I hope everybody got the email and they can also see the WhatsApp chat box. Everything has been also mentioned there. Okay. Okay, thank you so much.